Thank you, Doc pala. You reminded me. Anyway, those part that were not recorded are just the introduction. So we come up to your course now, which is Managerial Statistics. Your course code is GS244, and the description of this course will be the fundamental knowledge and skills that will be required to you in order to apply statistical methods in healthcare management. So we will be covering topics such as descriptive and inferential statistics in order to enable you to make data-driven decisions within healthcare organization. So our program or educational objective is that we hope that you will be able to apply your statistical tool and techniques to analyze your healthcare data for decision making, and you will be able to demonstrate your critical thinking and problem-solving skills in healthcare management. Okay. As students, we expect that by the end of this course, you will be able to analyze your healthcare data using your descriptive statistics at least. Okay, so this is a part of your action research. Hanggang dito. Pero again, your action research, by virtue of its being a descriptive design, pwede nyo pa rin naman siyang i-move on into inferential statistics. So again, other things are we expect you to apply your inferential statistics to draw conclusions and make predictions in healthcare settings. Utilize statistical software also to perform data analysis. That's why I asked you to prepare. Did you bring with you your Excel files, Excel applications? Okay, because there are many tools that you can use in your statistical analysis that will help you analyze and eventually make conclusions. No? So, ang statistics kasi sometimes you need to perform some statistical method in order to arrive at a certain output, and usually you make this output as a basis for your decision, whether to accept or reject your hypothesis. So you need sometimes tools na would make your life easier, like for example, Excel, para hindi na kayo maglo-long method. Okay, we will be talking about the applications as well. So last is we expect you to at least communicate your statistical findings effectively to support managerial decisions in healthcare. Okay? So statistics, like anything, can be taken to the extreme, but again, it is not the need or the intent of this course to do that. We don't expect you, or we are not here to make you as statisticians. Okay? Rather, we are here to learn the principles on how to interpret your data, okay? On how you're going to make conclusions, not necessarily to make computation. So we have specialists for that. So it's not the intent of this course to make you as a statistician. So pag meron, sabi nga natin, pag merong iba na mas nakakaalam, we will leave that expertise to them. Kasi in computation, garbage in, garbage out, pag meron ka lang isang decimal na mali na input, it will affect all the result. So might as well ask the expertise of a statistician to help you with the computation of your statistical test, and then your statistician will give you the result, and it will now be your responsibility to interpret the outcome or the statistical process of this statistical process. Okay, so huwag kayong mag-alala. We will not be talking about computations in your exam, kasi being healthcare managers, I don't think na meron pa kayong oras gagawin. So you just have to call your friendly statisticians, and they will do the computations for you. But mind you, your statistician will not do the conclusion. No? Pag binigay nyo yung data nyo sa statistician, hindi siya yung gagawa ng research nyo. You still have to do all the process except the computation part. No? Although I will also teach you on how to compute, pero not necessarily that I expect perfection from you. So baka magkaroon pa rin kayo ng pagkakamali. So you still need the help of a statistician. But at least, alam mo kung ano yung sinasabi mo sa statisticians ninyo. Diba? So pag binigay mo yung data, tatanungin ka ng statistician, Doc, anong gagawin ko dito sa mga data na ito? So if you have the knowledge about statistics and research, hindi ka niya mabablock, hindi niya alam mo kung anong gusto mong hanapin sa kanya. So these are my data, these are the type of data that I have. I wanted to do this, to do that, because you know the principle. Okay? And then eventually, pagka nagawa ni statistician yung computations, ibabalik niya sa inyo, walang conclusion. So kayo ang gagawa ng conclusion because you know better. You know what you are looking for. Okay? So that's what we are going to learn. How to interpret your data and eventually make a sound decision from it. Okay? So in this course, you will learn how your processes speak to you in the form, of data. Then if you are to understand the behaviors of your process, then you must learn to communicate with the process in the language of data. So our vocabulary, we will communicate with each other with a common vocabulary or language, which is data. We will talk about numbers, okay? Nothing else. So we will communicate with numbers. So this will be the language of our discussion, okay? And as well as with the proceedings of your research, you will talk about data, nothing more. So in terms of statistics, okay, this will provide you the tools and techniques, okay, in order to process your data, and eventually you can analyze it. And then when you have that information, in order to get that information and knowledge, wherein you're going to use it in your decisions to manage your process. Okay, so we can apply statistics in so many ways. No? You can see your statistics in your daily life. You can see them in the surveys, in marketing, in business, in healthcare, especially with you being managers, healthcare managers. We use statistics in order to plan usually health programs in your hospital and in your community that will address your health problem. So in each of these aspects and many more, statistics becomes an important tool in decision making because our goal, being managers, being executives, we will be trained to decide based on data. Our goal here is to make you decide based on numbers. Okay, you fight with numbers, you decide with numbers, okay, and you get away with the usual practice of decision making basing on your just simply what you think, what you feel, in your opinion. No? So dapat hindi na being managers, hindi na kayo mag-isip. So we will teach you on how to make decisions, okay, wherein those decisions should be based on numbers. So you speak, you fight, okay, you decide using data. Okay? So that hindi kayo magkakaroon ng problem and you will surely get the best result. Okay. So your textbook, again, I don't expect you to get a book, no? Any reference is good enough. Kasi ang statistics, lalo na sa statistics, wala kang makikitang librong magbibigay sa iyo ng dire-diretsong discussion eh. And usually, ang magagandang statistics book ay yung mga sa engineers. Makikita niyo sa yung mga libro ng engineers, mas kompleto doon. Pero otherwise, wala pa akong nakitang isang textbook na will discuss everything and anything about statistics in a single setting. No? So, otherwise, we can still have these textbooks. This will be the recommended textbook that you can. Okay. So statistics, medyo how do you see statistics taking this course? How do you see yourself taking statistics? Anyone? What is your impression about statistics as a course?
Mahirap to kasi parang sa medical course hindi masyado naman yung ano yung math.
engaging, no? Parang these are for the seasoned mathematicians or mga epidemiologists, no? Yes, of course. So in our course kasi, statistics is a 2 years course when you take epidemiology. But with us, we will take these 2 years, we will compress it in 2 days, and we will finish the statistics by then. Yeah. So I don't know how we're going to do that, but we will make it as simple as possible and as interesting as possible. Okay. So going back, statistics again can be formally defined as a science which deals with the collection, when you start collecting, when you start organizing, and ready to analyze and eventually interpret your data. That will be your commencement of statistics. Okay, so statistics means this is the science or the methods of collecting, summarizing, analyzing, and eventually making inference or conclusion about your data. While a statistic is the information that is expressed is in numbers. Okay, so your measure of central tendency, which is your mean, your median, your mode, are statistics. And the results that you get from them, the numbers that you get from them, is called statistic without the S. So statistic is the number, statistics is the method. So there are many ways, okay, in which you can view your data. No? Paano mo i-describe yung data? Remember the basket of fruits? There are many ways wherein you can give information about that basket. Okay, so one of them is to use statistics in order to describe the information that you have about your data or about that basket. Okay, so in statistics, you can describe your data in 2 ways. You can do your descriptive statistics, or you can do your inferential statistics. So meaning, again, if these are your set of informations, there are 2 ways wherein you can describe the information here, okay, by using a descriptive statistics, or you can do your inferential statistics to give at least information about that set of data. Okay, so in statistics, this will be divided into two parts. We have the descriptive and the inferential statistics. So the activity or the things that you're going to do, okay, in order, when I ask you, can you give me information about the collected data? Okay, there are 2 ways that you can do. You can present your data by description, or you can do inferential testing. The activities or the things that you do in a descriptive statistics or descriptive way of summarizing your data is that you just have to collect, organize, present, and summarize what you see in that set of information without making any inference, or without making any, without asking informations if they are related with each other. So what you see is what you get. Like, for example, your class, I would like to get some information about your class regarding your scores in examination. So when I ask you that, the way you will describe your class or your data, okay, is just present it in terms of descriptive statistics. And the language that is being used by descriptive statistics is you just have to mention about the different measures of your central tendency, the different measures of dispersion, the frequency, and of course, a drawing or a representation or a graph. Okay, so you will talk now about the mean scores, the median scores, okay, the mode of the scores, the relative scores, variance, standard deviation, the frequency distribution, ilan ang ganitong, ilan nakikuha ng 80 to 90, 90 to 100. So you have to put them in a frequency distribution and also provide a graph. So those are the activities that you're going to do in a descriptive statistics. Okay, so when I ask you to describe your information or your data, okay, you speak with me, okay, or you tell me the information about that data in terms of using this different descriptive language or descriptive statistics as your language. Okay, so I expect you to describe the mean, the median, the mode, etc., etc. But when I start asking you about the scores and its relationship to other classes or to its relationship with other masteral degree or program, then that's the time that you're going to describe your data in terms of an inferential statistics. And the language that you'll be using to describe your data in an inferential statistics is by giving estimates and hypothesis testing. Okay? So, are you still with me?
Yes, Doc.
Medyo cranky lang ako nung nag-umpisa. Wala pa akong tulog kanina. Parang hindi ko rin masundan yung sarili ko. But anyway, as of this point, are you still with me?
Yes po.
Yes, Doc.
Yes,
So,
Doc.
Yes,
you have
sir.
a set of information. So nakapag-gather kayo, nakuha nyo lahat yung nag-experiment kayo. Kunyari yung class nyo, you want to know the hemoglobin level. So lahat kayo, 100 kayo na members of the class, you took the hemoglobin. Okay, so kinumpile nyo yan. So imagine 100 sets of data, 100 data sets that you're going to conclude or make any or get information from there. So when I ask you to present those hemoglobin level, okay, and give me information about that data that you have, okay, you're going to describe this data in terms of a statistical approach, which is your descriptive statistics, or it can be inferential statistics. So when I ask you, give me a descriptive summary or give me information using descriptive statistics about the hemoglobin levels of your class. So you will be describing your data in terms of what is the average or the mean hemoglobin levels, median, mode. So you will be using these different descriptors to report about the information of your data. Okay. But if I'm going to ask you, how is it related if you compare to other classes with the hemoglobin levels of other classes, then that's the time that you will going to report all this information in terms of the inferential statistics using estimates and hypothesis testing as your descriptors. Okay, this is how you will describe your data. You use the process of estimates and hypothesis testing. Okay. Maliwanag po ako. I'm still with you.
Yes, Doc. Yes, Doc.
Good.
Yes, sir.
So now we have to differentiate at least what a descriptive and inferential para mas malinaw sa inyo. When we say a descriptive data, a descriptive statistics, okay, when you treat your information using a descriptive statistics, you are going to allow this. You just have to describe your data set. You describe. You talk about, again, the measures of central tendency, you talk about the mean, the median. So you will just be describing your data without any inference. Okay, you are not trying to seek relationship or compare this result. So you will just have to simply describe what you see and what you get in a descriptive statistics. That is the only thing that you're going to report. But report it in terms of the descriptive stats. And what are the descriptive stats? These are the measures of your central tendency, measures of dispersion, and the frequency distribution. So you have to describe the characteristics of the response, such as average only, okay, or the relations between two variables. So wala kang conclusions, wala kang judgment na gagawin in a descriptive statistics. Okay, you just have to report what you see. Okay, in an inferential stat, you are going to make inference based on your descriptive stats. So kung ano yung mga nakita mo dito na mean, median, mode, okay? When you start doing your inferential test, you are going to make conclusions if it is related to some other variables with mean, median, and mode of some other classes. So you are now going to compare these things if they are related or parehas lang ba yung average na hemoglobin nyo at hemoglobin ng ibang klase. So this will now be your inferential statistics. When you do that, that is an inferential stat. But if you're just going to describe without making any conclusions with regard to the relationship between variables, then you are just doing your descriptive statistics. So in descriptive statistics, there is no uncertainty. So ibig sabihin, kung ano yung sinabi ko, I will not challenge you anymore. Hindi na kita tatanungin, yung bang hemoglobin level ninyo sa class ninyo can also be generalized with other classes, that we can safely say that the normal hemoglobin level of master's degree masteral students in JNU is like this, like that. Okay, you don't do that in a descriptive type of statistics. Okay, when you start asking relationship, that becomes an inferential. But in a descriptive statistics, you just have to present your data. Kung ano yung nakita natin, yun na yung magiging result. There's no question whether it is that significant or not. Like for example, pag nakuha natin scores ninyo is 90, average scores niyo sa exam is 90, okay? Alam na natin yun na 90. Hindi na natin i-prove if yung ibang klase na nakakuha ng 85, okay, are different or baka naman parehas lang. Okay, so that is your inferential statement. When you just compare the value 90 and 85, alam natin na may difference siya, na mas mataas yung klase nyo because 90 yung average nyo, while the other class is 85. So this is just descriptive. So no questions about that. Kung ano yung present mo, yun na yung makikita mo. Okay, because there's no inference that is being made. But once you do try to challenge if there is a difference between a 90% and 85% in actuality or in the real world, then that's the time that you're going to do your inferential stuff. Okay, so in descriptive statistics, okay, you will going to report your characteristics or your informations or your findings about your data in terms of the distribution, the central tendency, and the variability. Okay, so the distribution meaning to say the frequency, the count. How many got this hemoglobin level of 90 to 100, 100 to 110, 110 to 120. So frequency meaning to say you have to count kung ilan yung mga nandun. So you describe your data that siguro mga 10 sa inyo got a level of 90 to 100 hemoglobin level and so on and so forth. So that's what we call distribution or frequency distribution. So you will describe your data in terms of this and the different measure of central tendency. So you talk about the mean, the median, and the mode. And the third one is the variability. So variances, like for example, the standard deviation or differences, yung mga outliers, yung mga kakaibang scores, no? So this is how you describe all this information. This is the language of your descriptive statistics. Okay, so again, when you use a descriptive statistics, these are the three language or these are the three informations that you're going to use in order to describe a certain set of information. While in your inferential testing, the two main ways of reporting the characteristics of your data is by providing estimates and hypothesis testing. Okay, so is that clear? Am I still with you, guys?
Yes, yes.
Yes, Doc. Yes, Doc.
Question.
Yes, Doc.
Are the language or what are the information that you are going to provide when you use descriptive statistics?
Distribution, central tendency.
Okay. What are the different types of distribution?
Frequency.
Frequency distribution. Okay. The central tendencies. What can you
Mean mode. Mean mode, median.
Okay. And variability?
Skewness.
Yes, yung mga ganon. May skewness, variance, and standard deviation. Anyway, we'll be talking about that in detail naman. But at least I know now that when I ask you to describe your data, you are going to provide me with this information using this descriptor. Okay. But when I ask you to make an inference, ano ang language or ano ang ipipresent nyo using inferential statistics?
Estimate and hypothesis.
So you provide me with information about estimates of your data, or you test the hypothesis. So meaning to say yung estimates, di ba yung hemoglobin level, tinignan natin doon sa class ninyo, can you give me the estimates, at least an average estimate of the hemoglobin level of your class? So bibigyan mo ako ng estimates. Siguro ang estimates, ang mean natin or the average hemoglobin levels is nasa 110 to 120 in respect with your class. Okay, so you're giving estimates. While your test hypothesis is that, kunyari, is these differences in your hemoglobin level within your class may pagkakaiba ba? So then, you're going to test your hypothesis. Kasi yung hypothesis mo will be, no, there is no difference actually in the hemoglobin levels of your class. Yes, there is a big difference in the hemoglobin level. So when you start testing this one, you're doing your inferential test. Okay. So again, your descriptive statistics is just you're going to look for a particular event and explain them. Okay? Look for a particular event and explain them without confirming or without establishing any reasons of relationship. In inference, okay, you are going to get the data from your descriptive statistics and then you start challenging. Okay, ask confirmation. Ask if there is a relationship between those collected data with each other. So this is the inferential portion. Again, when you use description, you are going to use the different measures of central tendency, which is your mean, your median, and the mode. Okay. Or you can use and or, no? It is better kasi to present them in three dimensions, no? Kung pwede mong i-mention lahat ang mga information about the mean, the median, the mode, the range, lahat sabihin mo yan so that you will picture your information in a three-dimensional presentation, no? Kaysa sasabihin mo lang, i-mention mo lang yung mean, parang one dimension lang yung nakikita mo. But if you talk also about the media and the mode, then medyo mas well-rounded yung presentation. Okay, so again, the descriptions that you're going to use for descriptive stat are your measures of central tendency, the measures of dispersion, which is your range, variance, and standard deviation, and your frequency distribution, your rates, ratios, and proportion, and of course, your graphical description. So this is the activity of a descriptive stat. While your inferential stat, the main activity is doing estimates and hypothesis testing. Okay. So your descriptive, you're going to break down and simplify your large data. You transform them and make them manageable in order to be analyzed. Okay. And then take note that your descriptive stat will just end up to organizing and describing your data. But once you start to infer, okay, you will go or you will move on into inferential stat. Okay, so ibig sabihin, you cannot do your inferential testing without doing your descriptive stat. Kasi yung mga data, the informations from your descriptive stat, okay, yun yung gagamitin mo for inferential testing. So in your inferential test or inferential statistics, you will be talking about you will be generalizing or making conclusions about the mean, the median, and the mode, or about the information that you get from descriptive. So it will be a continuation. So descriptive can stand alone, but inferential tests cannot proceed without gathering information from your descriptive stat, because this will be the information that you're going to use when you do your inferential testing. Okay, so descriptive statistics is just to summarize, summarize and organize your characteristics of the data by simply describing it as it is. What you see is what you get. Kung ano yung nakita mong mean median mode, yun ang i-present mo without any inference. Okay. But in inferential statistics, you will have to make inferences and eventually come out to a certain conclusions and make predictions of your data set. Okay? So maliwanag na tayo doon. Very, very detailed yung differentiation natin ng descriptive stat at inferential stat. So at this point, maliwanag na. Okay? Any more question para hindi kayo malito kung ano yung gagawin natin if we're doing a descriptive statistics or an inferential statistics? Any question before we proceed? Okay na tayo? So again, you have the sets of information. I want you to give me information about this data. So what you're going to do is you can describe by using the different measures of central tendency, measures of dispersion, and frequency plus your graph or a drawing of that information. Or you can do your inferential statistics, okay? And then you will be talking about estimates. And here you're going to test your hypothesis, okay? Whether there is a relationship between variables. Okay. Are we clear with that? Are you still with me?
Yes. Yes.
Yes, Doc.
We're now ready to proceed with the first branch or first part of your statistics, which is descriptive stat. Can we proceed?
Yes po.
All clear. So malinaw na. Kasi baka hindi na natin mabalikan ito sa dami ng ating pag-uusap. Okay, so let's start with descriptive statistics, and then after talking about descriptive stat, papunta na tayo sa inferential stat. So for now, we will finish the descriptive statistics. So what is a descriptive statistics? This will cover all the aspects of collection, classification, summarizing, presentation of data that's gathered from the members of a set. The members of the set, ibig sabihin, the population, in order to describe or present them using graphical description, tabular presentation, and your summary statistics. Summary statistics is your MCT, MOD, okay, your tabular is your frequency, and your description is your graph. Okay? So, ito dapat ang mga components na makikita natin sa descriptive stat. So, descriptive stat is simply summarizing the characteristics of a set of data, okay, as it is. Okay. No establishment of relationship. So kung ano yung nakita mo, yun lang i-report. So like for example, this is your raw data. This is your collected data. Okay. If you try to look at this directly without arranging them into a presentable form, you will not get any information. So when you have this information, I would ask you, so give me some information about this data that you collected. So what using descriptive statistics. Okay, so when we say descriptive statistics, we just want the summary of information. So you will summarize information in terms of talking about the frequency distribution. So you rearrange this one maybe from highest to lowest. You make groups, no? So this will be an example of your frequency distribution. So according to age and gender, so nilagay mo doon male, ilan ba male, ilan ang female. So you're making a frequency distribution. This is one way of describing your data. The next way to describe your data is to draw it. Okay? Draw your information. Give me a drawing para mas maintindihan ko ng mas mabilis at mas maganda. So you draw your information in terms of providing your graph. So yung mga information dito, gagawa ka ng graph para sa kanila. Maybe in terms of a pie graph or bar graph, histogram, anything. Napag-aralan na natin lahat yan kung iba-ibang technique on how you can appropriately present your data, right? Okay, so after providing a graphical summary, you now mention about the mean, the median, the mode, which are the measures of your central tendency, and then you also have to talk about the measures of dispersion, which is all about the range, variance, and standard deviation. So this is the summary descriptive statistics. Okay. Maliwanag? So when I ask you to give me an information about this one, I would expect you to present this raw data in terms of a frequency distribution, graphical distribution, measures of central tendency, and measures of dispersion. Okay. So therefore, to challenging, it's like the other two, you can quite support that. Okay. Just let me know, pwede kayong magtanong agad-agad para I don't mind if you raise question immediately para hindi nyo makalimutan at hindi tayo mawala sa track. I would prefer a impromptu discussion rather than talking about it going back. So you can just open your mic and participate in the discussion. So your descriptive statistics, this will be your summary. So this will be the events that you're going to do or you present. If you have this information or this set of data, your descriptive statistics will be all about frequency distribution, which is your rates, ratios, and proportion, or the central tendencies, which is your mean, your median, and the mode, or the dispersion or variations, which is your range, standard deviation, and variance. Nilagay ko lang yung standard of error dyan, pero maintindihan nyo mamaya kung ano itong standard of error. Standard of error is also a statistical process that can be a descriptive stat and can also be an inferential stat. So nilagay ko lang dyan just to make differentiation later. We will be discussing that. And of course, don't forget the graphical presentation as part of your description. Okay. So there are four main functions of descriptive statistics: to carry out the measures of central tendency, to calculate the measures of dispersion or variability, to show the frequency distribution, and to show a graphical presentation. Okay, paulit-ulit to. So in order that your description will be complete, all the informations about measures of central tendency, dispersion, distribution, and graphical presentation should be present in that summary. Okay? Nandun yan sa conclusion mo. So, pag ginawa mo na yung conclusion mo about the data, so my data has mean of, mode of, median of, range of, so you have to describe this one in your conclusion or in your analysis question. Okay, so what are the differences of the measures of central tendency and measures of dispersion? Okay, when you say measure of central tendency, this will be the index of clustering of values towards the central value. So you have to look at your data in relation, okay, so this is your individual data, in relation to the center. So these are the measures of central tendency. So you are looking at your data and compare it to the central portion, which is your mean, your median, and the mode. When we say measures of dispersion, you look at your data, how far are they from the center? So measure of central tendency, how close they are to the center. But when we talk about measures of dispersion, we will be talking about how far your data are from the center or how different are they. Like for example, nag-exam kayo 1 to 100. No? So karamihan sa inyo nag-gravitate sa 70 to 80 ang grades. Tapos may isa sa inyong nakakuha ng 20. Tapos may nakakuha ng 99. Okay? So these are the things that we are looking in a measure in a dispersion. So how far your 20 and your 99 from the usual center, which is 70. Okay? How far? How variable? How different? How ang tawag doon? Variable. How different or how far it differs from the center. While your central tendency, how close, okay, your data set resembles the center. Okay, do you understand? So when we
Yes,
talk
Doc.
about median and mode, we usually take a look at the center. Sa mga issues about the center. Okay, yung mga data that are located in the center. When you talk about dispersion, we will be talking about the data that are away from the center. So sino yung mga outliers? Ito pala, sasabihin ko dapat. Mga outliers or sino yung mga variables or yung mga different, very much different from the usual data. Okay. So when you say frequency distribution, it's just you just have to distribute them into groups. Okay, so kunyari male, according to male, and female, according to color. So you just have to count them. Ilan ang female? Dalawa. Ang male, dalawa. Ang female, kunyari, 5. So this is how you're going to distribute this data. So that's why it's called frequency distribution. So 2, 5. Okay. You get the idea or the principle of doing a frequency distribution. You just have to present them in the table and then you count. You distribute them. So student 1, student 2, student 3, and then. So let's talk about the measures of central tendency muna. So there are 3 statistical methods for central tendency. So we have the mean, the median, and the mode. So the measures of central tendency is intended to provide an index of clustering of X values towards the central value. So you look at your data, how they are located in terms of the middle value, okay, which is your mean. So you compare your data, kunyari yung score ni Sir Ray, compare mo kung gaano siya kalayo doon sa average or sa gitna ng mga test scores. So we will be providing measurements with that later on. Okay. What does a mean or average, okay, says? So your mean or average summarizes the center of range values. So one single value that will describe the responses of the respondents in totality. So parang this will represent your mean will represent the totality of all your respondents. So it is the most commonly used method of describing the central tendency of your responses or your values, but it is sensitive to extreme values. Kasi when we say mean, dito lang tayo nakatingin. Hindi tayo nakatingin sa mga outliers, yung mga extremes, mga data na nandito. So if you are going to describe your data using the mean, okay, what we are only looking is the center. We might be missing those who are outliers or who are different or who are variants of the set of data. Okay, so it may not be appropriate statistical tool to use and apply to describe the center of the data if the data sets contain some very large or very small values of categories. So you will consider other types of measurement, like your mode or the median. So how are you going to take your compute for your mean? Okay, it is computed by adding the scores of your values or your responses in each condition and dividing them by the number of scores or values and responses. Okay, example 2, 3, 4, 5, 6, 7, 8, 9. What's the mean? You have your Excel or your calculator. Sige, magbukas kayo ng calculator. 2, 3, 4, 5, 6, 7, 8, 9. What's the mean? Anyone? Paunahan.
5.5.
5.5. How did you do that, Doc Mark?
Bale, i-add mo lang lahat, 2 plus 3 plus 4 plus 5 divided by the number of data, which is 8.
So that is the mean. So simple lang. So let's proceed to the median. What is a median? Median naman summarizes the middle of a range of values. So again, we are talking about the middle. Ang focus natin, ang mata natin ay nasa middle because we are talking about the different measures of central tendency. A median, in comparison with your median is the middle of a range of values. So if you can 1, 2, 3, 4, 5. So what is the middle range of these values?
3.
3. So this will be the exact middle score of number that is taken as the median when the item is added. What if dinagdagan ko ng isa pang data set? 1, 2, 3, 4, 5, 6. What is the median? What is the center? What is the middle portion of this data set?
3.5.
3.5.
1.5. How did you do that?
So, yung average nung dalawang gitna. So, 3 plus 4 divided by 2.
You sum, you get the average of the two middle values and that will become your median. Okay? Very good. So this is how you do it. You just have, if add numbers yung set of data mo, you just get the middle. If it is if it is even, you get the two central values divided by 2 and that becomes your median. What about mode? Mode, in comparison with the median and the mean, your mode identifies the value in a list of values with the highest frequency. What do you mean by highest frequency? The number of times it comes out or it is represented. 1, 2, 2, 3, 4, 5, 6. So what is the most commonly occurring number in here? What is the mode?
2.
2.
2.
And we call that
Mode.
mode or unimodal.
Unimodal.
What if 1, 2, 2, 3, 3, 4, 5, 6? What's the mode?
2 and
2 and
3.
3.
2 and 3. And we call that
Bimodal.
Bimodal.
1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. How would you call this one? How many modes?
Multimodal.
Apat.
What
Multimodal.
is?
Multimodal.
Okay, very good. So you now see the difference or know the difference between a mean, a median, and the mode. Mean is, let's go back. Mean is
Average.
average. Median is
The
Mid-
middle.
mid-range.
the middle or the
Middle.
center. And the mode is
Highest frequency.
highest frequency. Okay. So, yan. Sample. Find the mean, median, and mode. Mabilisan lang. Describe your data. Kunyari, ito yung data na na-collect mo. Okay, ang tanong ko ngayon, please describe your data in terms of the measures of central tendency. So when I ask you that, of course, you will be providing me the measurement of your mean, your median, and your mode. So what's your mean?
22.75.
22.75. What's your median?
25.
Your mode?
And 10.
Okay. So when you report to me this one, you are describing now your data in terms of your measures of central tendency. Okay. Any questions so far?
None, sir.
Sir.
Okay. There are just some things that I would like you to consider when you are using these descriptors because they have corresponding uses. Okay, there are characteristics or requirements for them to be used properly. When should you use the mean, the median, or the mode? So the mode can be used for any level of measurement, but it is most meaningful for nominal and ordinal levels. Okay. Tandaan niyo yan, The median can only be used on data that can be ordered. So ano yung mga na-order natin? These are the ordinal, interval, and the ratio type of data. Okay. So take a look at your data. If your data are nominal and ordinal, it can be best described using the mode. If
Mode.
it is ordered in terms of ordinal, interval, or ratio scale, it can be best described using median.
Median.
Your mean naman can only be used with interval and ratio levels. Like for example, you're reporting about temperatures, you are reporting about hemoglobin levels or weight. Okay, it is best to describe your data using mean. Okay, your mean cannot be used or is not proper to use in a nominal or ordinal levels. Okay, it is better if you're going to use the mode as your main descriptor. Okay, you get that point. So this to decide which measures of central tendency to use, you should also consider the distribution. So all three measures of central tendency, meaning your mean, your median, and your mode, are for normally distributed data. We will be talking about this one later, what are normal and what are abnormal data. And your median is the best measure for skewed distribution or abnormally distributed data. Okay, so just remember this for now. So in summary, when you are dealing with nominal data, the best descriptor of the measures of central tendency is mode. Example, if you talk about ethnicity, political, ideologies, no, which is your descriptive, di ba? Ito yung descriptive design. Okay, you talk about mode. But if your data is ordinal, the best that you can use is your mode and your median. Okay, orders, meaning to say, di ba, may mga levels, income bracket. So you use the mode and the median as your descriptors. But if your data are interval and ratio, okay, you can use any of this. You can mention about the mode, you can mention about the median, and you can mention about the mean. And mode is for abnormally distributed data. Mode, median, and mean are for normally distributed data. Okay. Are we clear? Is there any question with the measures of central tendency?
None, sir.
Okay, so let's proceed to the next descriptive stat, which is the measures of dispersion. What are the different example of measures of dispersions again? Hindi pa lang. So the different measures of dispersion includes your range,
Variable standard deviation.
variance,
Standard.
and
Standard deviation.
okay. So measures of dispersion is also called the measures of variation, meaning to say differences. Okay, how different are you? How far are you from the usual or from the average? Kung gaano ka kakaiba, no? Yung outliers, kakaiba yung mood mo, kakaiba yung scores mo, kakaiba. Hindi ka parehas sa middle or the average population, average person in the group. So your measures of dispersion is used to calculate and know the spread of set of data. So your dispersions or variation means the spread of data around the central tendency. So variability describes how far apart your data points, no? So your variability will measure, will describe how far apart from you from the center. Okay. Yan. Yan. So, sino ang pinaka-variable dito sa mga ito? Ito. Okay, so as you go closer to the middle, the more likely na magiging kaparehas ka ng middle. So you become less variable, less variant, or less different from the other. Okay. So while the central tendency or the average tells you where most of your points lie, your variability summarizes how far apart they are. So this is important because it tells you whether the points tends to be clustered around the center or are more widely spread. Yan. If you have the center, titignan mo yung mga sets of data mo, nandito ba yung mga sets of data mo, or are they widely spread? Mas malalayo sila dito sa center. Okay. So this is the picture that you are depicting in dispersion or measures of dispersion. So data sets can have the same central tendencies but different levels of variability or vice versa. Now, if you know only the central tendency of a certain variability, you cannot say anything about other aspects. So that what I'm saying is, again, when you try to describe your data, you do not only report the different measures of the central tendency, but you also mention about the measures of dispersion so that you will see your data in more dimensions, no? Rather than just a single dimension na nakikita mo lang yung harap. But if you combine measure of central tendency and your measures of dispersion, you will create an information that is more well-rounded. Okay? So your variability is also called spread, scatter, or dispersion. So there are 4 statistical methods of dispersion. We have the range, okay? Along with this is an interquartile range. I explain ko sa inyo mamaya kung bakit natin in-include yung interquartile range. Interquartile range was discussed in your graphical presentation, right? So we have the variance also and the standard deviation. And ikinoconnect lang natin yung standard of error because this can be your inferential statistics. But it can also be a descriptive stat. I will tell you why later on. But the 4 statistical methods of dispersion again is range, interquartile range, variance, and standard deviation. Okay, are we clear on that?
Yes, sir.
What are the different measures of central tendency?
Mean,
Yan.
mode,
Mean,
mode, median.
Okay, so for dispersion,
Range,
Range,
variance,
variance,
standard
Variance,
deviation.
standard deviation.
very good. So i-memorize niyo yan, ha? Okay. Let's talk about the range. Range will just simply be the highest value minus the lowest value. Okay? It is a very crude measure of variation because what you see is only the tip, the beginning and the end, or the points of ending and beginning. So you will be talking about the lowest number and the highest number. So you get lost of your sight of what's in the middle. That's why it is crude measurement. Okay, so you can get an extreme scores that affects the result to a misleading range. So I will give you an example. 10, 10, 25, 25, 30, 30 to 40. What's the range?
30.
30. So how did you do that, Doc Mark?
Yung highest and the lowest score, which is 40 minus 10, so 30.
So your range is just the highest minus the lowest score. So that will be the range. Okay. What about an interquartile range? So we said a while ago that a range is a very crude measurement because you only see the outliers or the extremes. So that if we make it into an interquartile range, meaning to say we will divide this spread into 4 quadrants, okay, it would be more specific. Okay, malalaman natin ang values in between. Okay, so it will be better than just simply using your range. Okay, so what is an interquartile range? So na-discuss na natin to, di ba? The interquartile range give you the spread of the middle of your distribution. So when we talk about the interquartile range, we talk about the middle. Okay, so this is the value of the middle. The interquartile range gives a consistent measure of variability for skewed as well as normal distributions. No? So just like the range, the interquartile range uses only 2 values in its calculation. What are the 2 values that you use in your calculations for the range? What are the 2 values?
Highest and the
Highest
lowest.
value and the lowest
The lowest.
value.
Okay. But in an interquartile range, the 2 values that you will be using in computation is also dalawa lang. This will be your third
Middle half of
interquartile
the
and the
25th and the 75th percentile.
75th percentile. Yan. Yun yung report ni Sino nag-report nun dati? Apple
Doc.
yata, no?
Yes, Doc.
So every distribution can be organized using a 5-number summary. So we have this one. The lowest value, okay, this will be the highest value. So your highest value will be your fourth interquartile, and the lowest value is 0. Okay, if you divide it into quartile, the middle will be your
50%.
50.
Q2. Your Q1, first quartile will be your Q1.
25.
And the
Q1.
amount of this is
25.
5. From this to this will also be 25. So that your interquartile will be at 50. That is the middle. And then if you divide Q2 and Q4, you get Q3. And the value of here is 25, and this is 25. And the value of this will be
75.
25.
25. Okay. For any distribution that is ordered from low to high, the interquartile range contains half of the value. So we will be talking about, I will be asking you what is the value of your IQR or interquartile range, meaning to say you will be talking about the value of your middle, which is your Q2. Now, how are we going to determine the value of your Q2? Okay, while the first quartile one contains 25% again of your values, the fourth quartile contains the last 25 values, right? 25, 25. Okay. In that means, okay, so I will give you an example. This is a set of data. Your scores, kunyari ito, nag-exam kayo. The scores are 72, 110, 134, 190, 238, 287, 305, 324. Find the interquartile range value. How are you going to do that? Doc Apple, can you still remember how to do that?
There are steps po, Doc.
Yeah. Mhm.
The
So,
first step is to i-arrange sila. So naka-arrange naman sila lahat from least to
Range them
greatest.
from highest or lowest to highest. Okay, and
Yes.
then
And then identify the lowest extreme and the upper extreme.
okay. So this
So the
is
lowest extreme here is the 72,
and 3 to
and the highest extreme is the 324. And then next is find the median.
Mhm.
The median here is the between 190 and 238.
No, we have to compute for that muna. Yun ang reason natin. Hindi natin alam yung interquartile range. So we have to compute for that. So how are we going to compute? You have to multiply the number of values of data set. Ilan yung data set natin is 1, 2, 3, 4, 5, 6, 7, 8. Okay. By 0.25 for the 25th percentile. So we want to see the value of Q1, Q2, somewhere here dapat, Q3, and Q4. Okay, so first step is to look for the value of your Q1. So the value of your Q1 is, in order to determine where is your Q1 here, you get to get the percent, which is 0.25 for Q1, multiply it with your data set. So 0.25 times 8 equals 2. Okay? And then you, ibig sabihin, this 2 will be your second data set. 1, 2. Okay, so your 110 represents your
Q2.
first,
Q2.
first
Q1.
Q2.
Q2 mo is middle eh. So,
Q1.
if you want to know the value of your Q3 naman is, Q3 is 75, di ba? 75. So 0.75 times the number of data sets is 8. So it becomes 6. So you count again. 1,
Value.
2, 1, 2, 3, 4, 5, 6. So the value of your Q3 is 287.
287.
Now, hindi ito ang gusto natin. Ang gusto natin is the value of Q2, which represents the interquartile range, right? So what you're going to do is you get the value of your Q3 minus the value of your Q1, which is the Q3 is 287. Okay, 287 less the value of Q1, which is 110, then it becomes 177. So your 177 now is your interquartile range, which is equivalent to your Q2. So somewhere, saan mo makikita ang 177? Okay, nandito. Somewhere here ang 177, which corresponds to your Q2. So your interquartile range will be at this. Okay? Kita niya?
Yes, Doc.
Tingin natin, baka nandito yung interquartile range kasi simply it is in the middle, right? But if you compute for the interquartile range, which is more specific than just looking at the range, which is 72 and 324, your interquartile range predicts or points out to a more specific value. So alam natin that the interquartile range of this data set is 177. Clear?
Yes.
Sir, question.
Yes.
Chrissy po. Question, sir. Sir, yung quarter 1 and quarter 3 is always constant. Yun talaga palagi yung gagamiting.
Yeah, I mean, the equivalent quartile value, 25, 25, 25 kasi. So from here, so your first quartile is 25, right? From your quartile 1 to quartile 2 is another 25%. Quartile 2 to quartile 3 is 25%. And quartile 3 to quartile 4 is 25%. So that the value of your quartile 3 is 25 plus 25 plus 25 is 75. Okay? 0.75. And the value of your quartile 1 is ito lang, 25. That is 0.25. Okay. And if you want to know the specific data set where it belongs, in quartile 1 mo, you should just have to get the value of the quartile, which is 0.25, and the number of data sets, which is 8, and then kung ano yung lalabas, that will be the position of your first quartile. So that will be 1, 2. So the value of your quartile 1 is 110. Okay, and so on and so forth. Liwanag?
Okay, sir. Thank you po.
Question? None? Let's proceed. So the second measure of dispersion is variance. So what is a variance? Variance reflects the degree of spread. So how far are you from the center? How variable are you? How different are you? Excuse me. So variance is concerned with the extent to which the values of a data set differ from the mean. Okay? Variance reflects the degree of spread of the data set. And the more spread the data, the larger will be your variance. So it is expected that if you have a higher value of your variance, okay, compared to 1 and 6, which is more variable, which is more spread out. 1 or 6? Anybody? Hello? What is more variable? 1 or 6?
6.
C.
6. Okay. So, meaning to say, the more the higher your variance, the more your data is being spread away from the center. So the variance is the average of square deviations from the mean and deviation from blah 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 blah. Ito na yung computation tinatawag natin. But I don't want you to memorize this one. This is not your job. Okay, this is a statistician's job. But then, again, it will be nice to know. So I'll just have to mention it. So there is a formula for, I'm not going to ask you this in your examination and even in actual practice, no? Hindi ko kayo expect na i-memorize nyo ito. So I'll just mention it for your information. That a variance has a formula. Okay, it has two formulas depending on your data, the source of your data. If your data is coming from the whole population, like for example, 100 lang naman kayo estudyante na pinag-aaralan, so that is feasible, no? You can count them. So that is the total number of population. Okay? But kunyari naging 100,000 kayo, sobrang dami nyo nang isa-isahin, so we have to get a sample from that population. Okay, so if the source of your data came from the total number of population, ibig sabihin you were able to count the population, you're going to use the population variance. So this is the formula of population variance. Okay, take note of the N. Okay, wherein the population variance is equivalent to the sum of blah, 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 blah. Okay, wag na lang. Hindi natin pag-usapan yan. Mainis lang kayo sa akin. For the sample variance, ang formula niya naman is N minus 1. Okay, tandaan niyo lang yan. So how are you going to compute for your variance? You have to list down each score and find their mean. So kung binigyan kayo ng set of data, 1, 2, 3, 4, 7, 21, okay? You have to list down each score and then eventually first you find their mean. Okay? And then subtract the mean from each variance. Okay, kunyari 1 minus your mean. And then you square it, and that will become your variance squared. Ito yung result mo. And then, lahat ng ito, yung 2 minus m square, 3 minus m square, you sum it up. Take the sum of all the squared values of your variance. Okay? The sum of your variance. So, after this, you have to divide the sum of the squared variation whether you are using your population variant or your sample variance, which is most probably we always use the sample variance kasi nga mahirap i-study yung population. So, you divide it by n minus 1. Okay. Okay, mag-alala. Ano lang yan? Nice to know lang. Okay, so bibigyan ko kayo ng example dito. Example of data sets. Negative 10, 0, 10, 20, 30. So anong first step kanina is to put them into table and arrange them. So this will now be your data set. Andito na yung negative 10, 0, 10, 30, and 30. So other class din, nag-exam sila. So we have the values for the other class, 8, 9, 10, 11, 12. Actually, you can only analyze one set of data. Ang ginawa ko lang, meron akong dinugtong na set of data so that you can see the difference when it comes to the value of variance. No? Kaya nagsingit lang ako ng another variable or another set of data. But usually when you do your research, isa lang naman yung variable na ginagawa niya, di ba? You talk only about hemoglobin of your class and that's it. So wala kang ibang set. But now, naglagay lang din ako ng hemoglobin level ng ibang klase para just to differentiate what we mean of the values of the variance. Okay. So first thing that you do is you list them down. Second is you get the mean of your data set. So minus 10, 0, 10, 20, 30 divided by 5. So your mean will be 10. The second step is you get the mean and subtract it from the individual data. So your negative 10 minus the mean square equals 40. So 0 minus the mean square is 100. 10 minus the mean square is 0. And then when you're done with all your data set, you sum them up. You sum this one and the sum is 1,000. Okay, so the formula for your variance is the sum of all the squared values divided by n minus 1 because we're using the sample variance, not the population variance. Kaya may minus 1. So you get the value of 250. So let's go to the other side. 8, 9, 10, 11, 12. First thing you do is you get the mean. So the mean is 10. Next is you get the mean and subtract it from each individual value, square them. So 10, 8 minus 10, square, and so on and so forth. Then take the sum of all the deviated mean. So the sum of 41014 is equal to 10. And the formula for your variance is the sum of all the squared means divided by n minus 1. So the variance is 2.5. Okay. Ang sa inyo ngayon is to interpret. So, set 1 has a variance of 250. Set 2 variance is 2.5. Okay. Kayo bilang gagawa ng interpretation ng data na ginawa ni statistician sa inyo, describe to me the set of data in the language of variance. How would you describe your data? Anyone? Anyone? Andiyan na. Describe.
Your set 1 has a greater variance than your set 2.
Yes. So, di ba? So, simple as that. So, meaning to say, the variability of set 1, yung differences ng mga scores nila are mas widespread. Compare mo to the second set or the other class, mas dikit-dikit yung kanilang scores. Okay? Yung set 1, mas malalayo. Biro mo may negative 10 yung lowest, tapos yung highest is 30. Ito is 8 and 12. They are closer to each other. So, I mean to say, the differences in between your data are more condensed or not closer to each other. So, the differences is lesser compared to the other set, which is extremes. May mga extremes ka, negative 10 and 30. So, I will view your data. Pag pinakita mo yung data mo dito, malalaman ko na yung other class has lesser variability compared to your class, which is higher in variability, or your scores are more different from each other. Okay. Am I still with you?
Yes, Doc.
Okay.
Yes, sir.
If no question, let's proceed to the next measure, which is your standard deviation. Okay, what is a standard deviation? A standard deviation is another measurement or statistical procedure that is very sophisticated because it can measure dispersion. Your variance will only give us the idea how variable or how different are you from the middle. Okay? Pero pag tinanong ko yung value, gaano ka kalayo from the center? I'm 1 kilometer away, 2 kilometer away, 3 kilometer away. Your variance cannot answer that. But your standard deviation can answer a specific value, how far your data or your score from the middle. Because your standard deviation serves as a scale. It is a measuring scale. So standard deviation has values in between. So that a 1 standard deviation, 2 standard deviation, 3 standard deviation has values in them. So that if I will going to ask you what or how far are you from the center, I am 2 standard deviation away from the center. So therefore, you have a measurement. How far are you from the center? I am 2 standard deviation away from the center. Okay. Not like the variability, pag tinanong kita doon sa variance, how far? What is the exact value? Kung gaano kakalayo sa center? You cannot tell. Okay? Basta, kakaiba ko. Malayo ako diyan sa sentro. I am different from most of the population or from the data set. Ganun lang. But in standard deviation, you can specifically say the measurement. Okay? That I am 1 standard deviation from the mean, 2 standard deviation from the mean, 3 standard deviation from the mean. Okay, so standard deviation is a statistical tool to determine the homogeneity or the similarity of degree or dimension of a given variables. Okay, or even the heterogeneity or the degree of dispersal of variables. So both ways, you can vividly or can exactly determine, okay, the distance or how different are you from most of the population. So standard deviation is the average amount of the variability in your data set, and it tells you the average, blah, 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 blah. So this is the computation. So in short, there is also a formula for your standard deviation. So if you don't know the value of your variance, you have to compute for that. If you don't know the value of your standard deviation, you have to compute for that. And the way you're going to compute for the values of a variance and standard deviation is we have a formula. So yung standard variance and standard deviation, halos parehas lang yung formula niya. Kaya lang, the presence of the square root. Because variance, a standard deviation, is simply the square root of your variance. So kung alam mo na yung value ng variance mo kanina, 2.5, so the square root of 2.5, which is your variance, will become your standard deviation. But in cases na you don't know the value of your variance, you don't know the value of standard deviation, you can compute for the value of standard deviation using these two possible equations. So if you are looking for the population variant, you use this one. If you are looking for the sample variant, you use the n-1. So just the same with the variant. So again, the shortcut is if you want to know the standard deviation, if you know the value of your variance, you just get the square root of the variant. And vice versa. If you know the value of your standard deviation, you can just square your standard deviation and that becomes the value of your variant. Okay? Understood? So again, I'm bringing back these two sets. Okay, our mean is 10 and eventually our variance is 250, right? So if you square 250, what is the square root of 250? What is the square root of 250?
0.8.
250. Square root of 250 is
15.
15. Okay. What is the square root of 2.5?
1.5.
1.5. Okay. So now you know the variance with this data set. You know the variance of set 1. You know the variance of set 2. Now you know the standard deviation of set 1 and you know the standard deviation of set 2 by using the values of your variance. Okay? Or kung ang unang kinompute mo naman yung standard deviation, you just have to square 15 to arrive at 250. You square 1.5 to arrive at 2.5. Right? So now you have the value of your standard deviation. Okay, sabi natin kanina, standard deviation is a measurement. Okay, kunyari, you have a tape measure, ang calibration niya is 1, 2 centimeter, 3 centimeter, 4 centimeter, and in between we have 1 millimeter, 2 millimeter, 3 millimeters, 10 millimeters. So your scale for this set 1 is using standard deviation. So ang its scale, kunyari, ito yung ano mo, ito yung middle mo, 1 standard deviation, this scale is equivalent to 15. The next is another 15. The next is another 15. I-compare natin si standard deviation ng set 2. Okay, this is the mean or the middle. Your 1 standard deviation is equivalent to 1.5 instead of 15, right? The equivalent of set 2 standard deviation is another 1.5. Third standard deviation is 1.5. Okay. Are you still with me?
Yes, sir.
So the scale is different from set 1 and set 2 by virtue of the values that you get from the computation of standard deviation. So ang scale mo dito for every standard deviation is 15 points. Another 15 points. Compare mo dito, 1.5 lang. Okay? So that when you have the scores of, kunyari, magpa-plot ka dito, magpa-plot ka ng numbers, let's say nag-exam kayo ng 1 to 100 exam, The lowest score is 60. The highest score is 90. Sabihin na natin yung middle neto is 680. Ano? 70. 60, 70. Gawin na lang natin 80. Ayan. Okay. So if the middle is 70, okay, add 15 here. 70 plus 15, that will be 85. So that will be the value of one standard deviation is 85. So 85 plus 15, ilan yung 85 plus 15?
100.
100.
100. So that will be your value of second standard deviation. Okay, for the value of third standard deviation, plus 100,
15. 115.
150. So your scales now will be 70, 85, 100, 115. This is for the positive standard deviation. What about to the left? Ganun din. Meron ka ding scale doon. So,
Minus 15.
minus 15. 70 minus 15,
55.
5.
55.
Minus 15,
40.
40. Minus 15,
25.
25.
5. Tama ba? 25. Okay. So this is negative, positive 1 standard deviation, positive 2 standard deviation, positive 3 standard deviation. And on your left, this is negative 1 standard deviation, negative 2 standard deviation, negative 3 standard deviation. Okay, so this will now be your scale. So kung tinanong kita, nag-exam kayo 1 to 100, the highest is 60, the lowest is 80. You got the score of 90. Okay. I will ask you, describe your location or what is your location with that particular score from the mean.
You're near to SD.
Okay, so you are somewhere between 1 standard deviation. So you are somewhere between 1 standard deviation and 2 standard deviation. So 90 is somewhere here. So what you're going to report to me or what you're going to describe about your data with this particular set of data, you are within 2 standard deviation from the mean. So you have a measurement. Alam na natin na ang score mo is within 2 standard deviation. Ganito ka kalayo sa mean. Pag ang score mo is 50, nasan ka? If your score is 50, where will you be? You will be somewhere here, right? No.
Below, Doc.
Ito, below.
Negative 2 and
Between
negative
1 to
1.
2 standard
Tingnan
deviation.
kita kung ano yung position mo. What is your measurement? For a score of
Near negative 2S.
you are
Below 2 standard
between
deviation.
negative 2 standard deviation. Okay, very good. So you understand now that a standard deviation is a measurement of how far or how variable or how different are you in comparison to the middle. Not just like your variance will just tell you how far you are without a specific value, without a measurement. Sasabihin lang niya na, I am away from the middle. While your standard deviation is a measurement. Okay, naintindihan niyo na? You get my point?
Yes, sir.
Okay, so that your standard deviation would look like this. So standard deviation will be how much the average scores differ from the mean. So ibig sabihin how much you have a specific value. Right? Okay. So, ito yung mga scores natin kanina, yung kinuha nating set 1 tsaka set 2. Okay. So, anong standard deviation? Can you still remember the standard deviation ng set 1? You still remember?
15.
15.
Yung set 2,
1.5.
1.5.
Okay, so let's talk about set 1. So the spread of your score is -35, -20, -5. No. The spread of your score is -10, di ba? It start with -10. The highest is 30 something yata. Okay. So what is the mean of your set 1? You still remember the mean of your set 1?
Minus 10.
10.
Yung mean ng kabila.
10 din.
And then, parehas na. Okay. So yung mean, you need to say it should be at the middle. So take the middle value, that is 10. Right? For set 2, the mean is also 10. So your 10 should occupy the middle. Okay. So how are you going to calibrate your scale? For set 1, you're going to calibrate your scale using your standard deviation of 15. So therefore, 10 plus 15 equals 25.
35.
Okay, so the value of your first standard deviation in relation to set 1 is 25. Right? Okay, plus 15. Let's calibrate. Gagawa tayo ng measurement eh. Yung 25 mo plus 15 equals 40. So the value of your 2 standard deviation is
40.
30 plus 15 again. So the calibration for your 3 standard deviation will be
55.
55.
okay. And going to the right, to the left, you subtract 10. You subtract 10 from, you subtract 15 from 10. That gives
Negative
you
-5.
-5. Then again, that will be the value of negative 1 standard deviation. Subtract -15 from -5. It becomes -20, right?
20.
And then that will be the value of your standard deviation and so on and so forth. Okay. Now, if I'm going to describe your data, okay, and if we're going to plot it under a curve, there is also a corresponding percentage of a 1 standard deviation, 2 standard deviation, and 3 standard deviation. So these are the possibilities or the probabilities. The percentage will be the probabilities of being included on that standard deviation. Okay. So that a 1 standard deviation, positive 1 standard deviation, has a corresponding value under the curve, or meaning to say, for the whole population. Like for example, yung class ninyo. Okay. So your class is composed of 34%. Kunyari, 100 kayo lahat sa klase ninyo. You are 100 students in your class. So the equivalent of a 1 standard deviation is 34% of the total population, or 34% of 100. Okay? So when I ask you, what is the equivalent value percentage under the curve of a 1 standard deviation? This is fixed. This is fixed. What will be the value?
34.1.
34. And 1 standard deviation to another standard deviation, the value will be
13.6.
13.6. And the other quarter or the other standard deviation contains 2.1 or 2.5 approximates. These are just approximate. So that this is equally divided, no? So when I ask you what is the value between -1 and +1 standard deviation,
68.2. 68%.
so the
68.2%.
value of this one will be around 68%. Okay. What is the value between -2 and +2 standard deviation?
96%.
Roughly equivalent to 96 or 95%. Okay. So if let's take the third -3 standard deviation
99%.
positive, negative, positive, the value will be
99%.
99%.
9.9 or 99%. Okay. Let's leave it at that. Okay? So what does this mean? If you have a score of 27 dito sa set 1. Dito sa set 1, ito, set 1. For example, you have a score of 27. What is the equivalent standard deviation? Where do you belong?
Within +2 standard.
Within +2 standard deviation. Okay. What is the possibility that you will, if you get that exam, if you get the score of 27, what will be the possibility that you will be within 2 standard deviation?
95%.
Yes. Okay. 95% will be the possibility that you will be included in the range of plus or minus 2 standard deviation. Okay. What is the possibility of you having a score between -5 and 25?
68%.
68%.
Okay, so chances are you will belong to +1 or -1 standard deviation if your score, okay, will be somewhere between -5 and 25. So that is the meaning of all this in terms of this scale of the standard deviation. Are we clear? So this is summative. If you sum this up, this will be equivalent to supposedly 100%, right? Kasi this is the total population. But in reality, in statistics, we don't do 100%. It will always be 99.9999999 and so on and so forth. This becomes infinite because there is no perfection in life. There is no perfection in life. So that the tail of this curve will not touch down the base. So it will remain to be infinite 99.9. So now you realize why Safeguard claims that they can kill 99.99% of germs. Bakit hindi pa nila 100%? Nahiya pa sila, no? They realize that while Safeguard claims to kill 99.99% of germs.
Kasi 3 standard deviations lang ang kaya niya.
Yes. And because in reality, there is no perfection. It will always be 99.9999. Okay? So true to their claims, nagbigay pa rin sila ng possibility of an error or not being included in that population. Okay? So any question with standard deviation? Are we clear with that? So your range will have to mention about the highest and the lowest. Your interquartile range will be more specific in terms of the description where your data sets lies. Your variance will tell you how different you are from the middle or from the rest of the group, while your standard deviation will provide you specific measurements on how different are you from the rest of the group or from the middle. Okay? You get my point? You get my point?
Yes,
Okay.
sir.
So that if we continue on further interpreting this curve, okay, that we use as a scale for your standard deviation. So you have a population here. Okay, if you plot all this data under a curve or in a graph, you will produce a curve like this, so that it will represent the whole population. So 100% of this population belongs to this. So that if you add up, again, 2.5, 13, plus 34, plus 34, it will add up to 1 or 100. supposedly, right? Okay. So if you want to divide this population into measurements, we come up to this standard deviation. Okay. So the parts of this curve is the middle will represent what represents the middle? What values should be in here?
Mean.
The mean. The mean is in the middle. So a one standard deviation, meaning to say, is one standard deviation away, that is positive. This is negative. So this is one standard deviation, two standard deviation, three standard deviation, positive, standard 1, 2, 3, negative. And it has corresponding values. Okay? So how much of this population will fall under one standard deviation?
68%.
Positive one, I'm sorry. How many of this population is expected to fall under positive one standard deviation?
34%.
4%. So how many of this population would possibly fall under positive 2 standard deviation?
13.5.
Plus,
34 plus 47.5.
kung gusto ko yung
47.5.
how many of this population falls under this area from positive 1 standard deviation to positive 2 standard deviation, you answer 13. But if I ask you what is the portion of this population that would fall under 2 standard deviation, then
From mean to
From
standard deviation.
47.5.
so very specific ka. Alam mo kung ano yung gusto mo, you have the equivalent value for each scale, for each calibration. So that's what you mean by the standard deviation in terms of your distribution pattern. Yeah. So one standard deviation, meaning to say 34%. Right? Yeah. One standard deviation is 34%. One standard deviation below the mean is another 34% below the mean, above the mean. Okay? And this is empirical. So you always remember that negative 1 standard deviation to positive 1 standard deviation. What is the value? What is the percentage value?
68%.
68%.
Negative 2 standard deviation and positive 2 standard deviation,
95%.
95%.
5%. Negative 3 standard deviation, positive 3 standard deviation.
99.9%.
9.9%.
Okay, so this will be the possibility. Okay? So that kunyari, mag-take kayo ng exam. Okay. Given a confidence of 2 standard deviation, meaning to say, what will be the possibility that you get or you will land your score within 2 standard deviation?
95%.
95%. So 95% of the time that you will get to land within 2 standard deviation. What about the 5% remaining? Saan napunta yung 5%?
3 standard deviations.
No. Di ba 95%? It's supposed to be 100%. Where did the 5% go? If 95% is your chances of landing here within 2 standard deviation, what about
5%? 5%.
5% will
Outliers.
that you will not.
The 3 standard deviations.
No. It should not be the standard deviation. The 5% will mean that there will be 5% possibility that you will not get a score that belongs to
The range.
-2 and positive 2 standard deviation. Ganun. Okay? But if what is the possibility of taking exam that your score will fall within 1 standard deviation, -1 and 1 +1 standard deviation.
68%.
So what happens to the remaining of 68%?
32%.
100 minus 68,
30.
32. What happens to the 32%? What does this mean?
That's the chance that you will not get the scores.
4. Okay. So that, ito ginagamit natin, yung mga academician, yung mga nagtuturo dyan, di ba ginagamit natin yung standard deviation para i-deliberate natin yung mga scores ng ano natin, ng mga students natin. So that kung sinabi mong, ang gusto kong pumasa ngayon sa lahat ng class ninyo is 68 lang or 68% out of 100. Okay, so I can determine my margins at once. The passing rate today is out of 100. I want 68% to pass. So I will be using the margins of -1 standard deviation and +1 standard deviation. So out of 100, 68 ang pumasa, 34 ang bumagsak. Okay. Nagreklamo sa inyo yung estudyante. Halos kalahati daw ang binagsak nyo. Okay, so you deliberate. Sige na nga, taasan natin. Dadamihan natin passing average. So instead of using 1 standard deviation, okay, you opted a margin of 2 standard deviation and 2 standard deviation. So what will now be the expected number of students who will pass?
95%.
5% ang papasa.
So 5% na lang yung remaining.
Babagsak.
Babagsak. Mhm.
And then you became more
Considerate.
or forgiving or considering, ay, parang mataas pa rin yung mortality ko. Gusto ko konti na lang, konting-konti na lang yung matitira. I would increase my margins to
Deviation.
3 standard
3
deviation.
standard,
So ilan ang papasa?
99.9%.
Isa na lang yung madadali.
Babagsak.
Okay. So that's how we use your standard deviation as a scale of measurement. So that when you have a set of scores, kunyari nag-exam kayo, 100, okay, I want you to describe the scores of your data in terms of standard deviation, okay. Most of your students fell, the scores of the mean of your the mean scores of your students fell within 2 standard deviation. Meaning to say, nandito sila. Okay? 98% will be included in that area. Are we clear on that?
Yes, sir.
Any question? So let's see the chat group. Outliers. Yes, that's true, Doc Mark. Okay. Question on Doc. Why did we represent the IQR as a point along the data set? Isn't it a range and not a data point? It becomes a data point. I just would like to go back to Doc Mark's question. Kasi I want it to be very, very clear. The interquartile range. Yeah. It is not a range because it becomes a data point. Ang tanong kasi Doc Mark dito, question lang. Doc, why did we represent the IQR as a point along the data set? Because it has a very specific value. Your IQR has a very specific value which corresponds to the value of Q2. What is the value of your Q2 here? What is the value of your Q2?
177.
177. So this is a point. It is a single value. A range is from point A to point B. So there are multiple values in between when you say it a range. So it is safer to say, kunyari yung nag-dart ka, di ba? Yung dart, meron kang center, at tapos meron ganyan. So a point is a very specific value. When you say range, it can start here to here, yan, or here to there. So that a bullseye, if you want to consider a bullseye, a very specific point, and it should land here. But if you make a range, that a bullseye can be included when you go one circle around the point, okay, that will be a range. And still be within that expectation of hitting a bullseye. Parang you also hit the bullseye kahit hindi doon sa pinaka-center because you consider it as a range. So binigyan kita ng leeway na kung nag-landing ka doon, kahit hindi ka doon sa gitnang-gitna, still bullseye ang treatment mo da. Doc Mark, did I answer your question? Doc Mark? Wala yata si Doc Mark nung pinag-usapan natin yung tanong niya. Doc Mark? Are you there? Okay. Sige. Explain na lang natin sa kanya later on ito. So again, ang tanong is bakit daw point ang interquartile range? Because it has a pinpoint value. Okay? It's not a range. It is a single value. That's why it is called data point.
Doc, pwede follow up po?
Yes.
Yung Q2 po, it's supposed to be the median po, no?
Yeah, Q2 will be the median.
So it's supposed to be the average of 190 and 238.
The average, no. Because ito kumbaga yung, if you talk about median, the median will be the difference between 190 and 238. Okay, but we are talking about range, interquartile
Yes
range.
po.
So the middle, instead of considering this as your middle, okay, I get your point. Your quartile 2 is also considered as the middle of the data set, just like
Yes, Doc.
the median. But the way you will determine the center point is different from the median and the way you look at it in terms of an interquartile range. Yeah. But supposedly, both of them points out to the middle of the data set, the middle point of the data set.
Sir, can I follow up lang din doon sa...
Yes,
So
yes.
what you mean is that yung quartile 1, the value is at the 25th parang
Yeah,
position.
that's the 25th portion of
And then the quarter 2 is at the 50th position.
50th,
That's why it's the median.
it's the middle in a sense, no? But not a statistically defined as the median. Kasi pag sinabi mo nga din naman, nakuha ko na yung sabi ni Doc kanina, pag sinabi mong median kasi is the middle value. Di ba? Middle value. But if we talk about the interquartile range, this will be the equivalent of 50% of the whole spread. Which is 25 plus 25, that will be the middle, it's 50%. So that will be the equivalent of quartile 2. The reason why they don't have the same exact value because they don't portray a same picture. Because in the interquartile range, we are talking about the spread, while the mean median mode is we are talking about the center. Okay, so para magkaiba dyan. If I ask you what is the median of this data set, then you use the formula for median. And it will give you different value with the interquartile range. Okay, so with your interquartile range, it is still the middle, but it will be represented, possibly it can be represented by another value, which is 177 instead of 1, 2, 3, 4, 5, 6, 7, 8. So yung median natin, di ba? 190 plus 238 divided by 2, ilan yun? I did not try to compute for that. Can you compute for that? 190 plus 238 divided by 2.
214 po.
So kung ang median natin dapat is 214 if we talk about the measures of central tendency. But if we talk about the measures of dispersion using the interquartile range formula, you arrive at 177. So you see the difference? Bakit hindi 214 ang middle natin? Because we take a look at the picture in a manner of it is how spread it is. And then yung area ng spread niya, yun yung kinuha nating dimensions. Okay?
So sir, it's not the value, it's the position.
Yeah, most position, which will be represented by a value from your data set. You get the point? So, ganito yan. Yung, hanap tayo na. Yan. Di ba spread ito? When we talk about range, is the spread. How wide? So we're looking at a picture of this dimension. Okay? So we're talking about the spread. When you talk about the mean, we're looking at the middle. Ito lang yung pinag-uusapan natin. Kaya nga, yung spread mo dito, okay, we talk about the spread of this one. How from 72 to 324. Iba yung spread neto. When we compare it with the center. When we try to look at the center, this is what we mean by the center, the mean. Okay, but when we say how dispersed, how wide, we'll take a look at the extreme measures, this one and this one. When we talk about the mean, we don't take a look at those extremes. We don't look both sides, the ends. We just focus on the middle. We don't care about the values of this. But in a range, okay, we are concerned about this spread. So we are going to take a look at the of both ends. Okay, from the beginning or from the highest to the lowest. That's why they will give you a different picture also. Okay, so that we understand that if you say the mean, the mean is, nga na kanina, yung mean nyo, pag kinumpute nyo, ay yung median nyo is ito. Pag kinumpute nyo,
240.
240. So it should, no, the median, if you compute the median, wait.
214.
Yeah.
214
The
po,
median
sir.
is 214. It should be somewhere here in terms of median, right? That is one view, one dimension. Okay. Let's ikutin natin. Baka maiiba yung itsura niya. Let's make it 2 dimensions. Okay? Let's take the picture using an interquartile range. And when you computed for the interquartile range, the picture shows that the middle will be somewhere here, right? This will be for the interquartile range. For the central of tendency, this will be your in the point of view when you're looking at your data using central tendencies, the middle will be here. But when you take a look at that picture in the point of view of a dispersion, yes, in the view of a dispersion, ikutan ko nga ng konti ito, dito ko naman siya titignan. Okay, you will be viewing the middle on a different plane. So that, pag naging 3D na yan, makikita mo, instead of looking at it bluntly at one side, nandito yung middle mo, pero pag pinaikot mo itong dice kunyari na ito, okay, makikita mo rin yung ibang dimension. You get my point? They are viewed at different point of views. Okay? Your mean median mode, you are viewing it at one side. Okay, these measures of dispersion, you view it on a different side so that when you combine both of those, you will provide a better dimension and you will realize the picture of your data better rather than reporting it only by means of a measure of central tendency or by just reporting using the interquartile data. Okay. Are we clear on that?
Yes, sir.
Very good.
Yes, sir.
We will not proceed until hindi nyo maklear ha kasi it will just create confusion later on pagka hindi malinaw. So again, 68%, what does this mean? 68% of all individuals will fall within one standard deviation of the mean. Okay, 95% of individuals will fall within 2 standard deviation, and 99.7 will fall within 3 standard deviation. Okay. So, are we clear with the standard deviation? So, meron tayong outlier. Kanina, sinabi ko yung standard of error. Standard of error, sinama ko na siya dito sa descriptive stat, pero this is mostly used in the computation for your inferential stat. It becomes descriptive stat when we will just be using this to report on things in terms of another dimension, rather than doing an inference. So that your standard deviation is used to measure one variable or one data set your standard of error will be for more than 2 variables. Okay? So your standard of error is just like your standard deviation, but these are for multiple variable. Okay? Standard of error and standard deviations are both measures of variability, because later you will see the calibration will also be the same. The only thing is the standard deviation will describe the variability within a single sample, while your standard of error will be across multiple samples. Okay, so it's like this. If you are just going to analyze the standard deviation of one sample, okay, you use your formula for standard deviation. Okay, kung iniisa-isa mo lang ito, this becomes standard deviation, standard deviation. But if you want to go across all of them, pag sabay-sabay mo yung tatlo, you use the formula for standard error. This is
Standard error.
error is for more than 2 variables, while your standard of deviation is only for single variable. So that your standard of error will also look like your standard deviation. Okay? So instead of sasabihin natin standard deviation, we can call this as standard of error, 1, 2, 3, ganun. Okay? So parehas pa rin sila. So the way you compute it, ganun din. You set 1, set 2, you get the mean, you get the standard deviation, and then you calculate. Ganun pa rin. Ang magiging different lang nito is you are treating multiple variables, but you're still using the same scale. Okay, but the scale name is, instead of a standard deviation, we call this as a standard of error. But the same values of this one, values of this two, of different case of one standard deviation is also equivalent to 1 standard of error, 2 standard of deviation, 2 standard of error. Only that your error represents multiple sets or multiple variables. Your standard deviation is 1 set or 1 variable. Okay? Are we clear on that? So when are you going to use your standard error then? Well, it depends. If the message you want to carry out is about the spread and variability of a single data or group, yung isang set ng data, then you use the standard deviation. But if you are interested in the precision of the sample means, or you want to compare and test the differences between means of sample population, meaning to say multiple, then you use the standard of error as a measure. Okay? Any question? Any question? We're done with the different measures of central tendency, which is your
Mean, median, mode.
and mode. We're done with the different measures of dispersion, which is your
Range, variance, and standard deviation.
or you can use a standard of
Or
error if
multiple sets.
multiple sets. Okay. And with this range, we have a problems of using
Interquartile
range
range.
because it is very crude. We only see ends. We don't see the pictures in between. So we rather use the interquartile range if possible. Okay. So we've done with the first description, the second description, the third description. What is the third description that we need to know?
Frequency distribution.
Frequency distribution. So this will be all about your rates, ratios, and proportion. So let's proceed. So okay pa kayo? Are you still energetic or no more energy to proceed? Can we still have some more? Can I still push you more? Are you saturated or you want to continue?
Okay lang ako, Doc.
Okay, so can we use the 4 hours allotted for us? It's okay?
Yes, Doc. Yes, Doc.
Sayang kasi we have a lot of things to discuss para magiging para magiging ma-utilize natin yung kailangan nating delivery. Sabi ni Doc Amiel, ano to? Okay. Sabi ni Doc Ray, naubos ako, Doc. Napagod na siguro si Sir Ray. Sir Ray, pwede ka magkape. Pwede ka magkape para ano? Okay. Sige. I'll just have to summarize this again and again para hindi kayo malito. So, you have a set of data, right? In a basket. Marami kang data dito na naipon. Okay. So, tapos na yung research mo. Nagawa mo na yung question, objective, methodology. Yung methodology, nandito ka na, nakapag-collect ka na ng data mo. So, what's the next thing that you're going to do with the collected data? What's the next thing to do after collecting your data?
Organize.
Organize. Okay. So you organize. So after mo na organize, what we're going to do next? Ano nang gagawin mo?
Analysis.
Yes. You organize and present. And then now, if you have an organized data, you are now ready to analyze. Okay? Are you still with me?
Yes, sir.
Okay. So when you're ready to analyze, okay, how then will you going to analyze this data? How would you present? How would you
Through
do?
graphs, tables.
I'm sorry?
Statistics.
You're now ready to analysis means you are now ready to present the details of your data. Meaning you are now ready to describe your data. Okay? And in so doing, when I ask you to describe your data, you will describe it in the form of
Descriptive statistics.
descriptive statistics, which is called your summary statistics. Okay? So what do I need to know when using the descriptive statistics? What information you're going to give me? You talk about the different
Measures of
measures of centered tendency in relation to your collected data. So, sabihin mo, ano ang mean mo, ano ang median, ano ang mode. So, na-describe mo na. What are the other things that you need to mention?
Methods of the
That dispersion. Okay?
dispersion.
So, what's next?
Measures of frequency.
Okay. So, you can even present it in terms of frequency distribution. And furthermore, para
Graphical.
you can even paint the picture of your data by means of graphical
Graphs.
presentation. So we are now done with the details of the different measures of central tendency. We're now done with measures of dispersion. Now let's talk about the different measures for your frequency distribution. Okay. Are we clear now? Are you still with me?
Yes, sir.
Yes, sir.
If done, let's proceed to the different measures of your frequency. So the common frequency measures are your ratios, proportions, and rates. A frequency measure characterizes only part of the distribution. So frequency means how many times you fall into such category. Okay. So, nagkaroon kayo ng table tennis, kumbaga. So, scoring. So, first set, second set, okay, yung dual. Okay. So, frequency means how many times you got the ball. So, 1, 2, 3, 4, 5, 1, 2, 3, yan. 1, 2, 3, 4, 5, 1, 2, 3. This is frequency distribution. You are distributing the characteristics in different categories. So that is your frequency distribution. And what you're doing is a frequency measure. So you are characterizing only a part of this distribution, and frequency measures compare one part of this distribution to another part of another distribution, and eventually to the entire distribution. Maliwanag ba yung sinabi ko? Yeah. So again, you are comparing the counts here over the counts of the entire population. So we have the ratios, proportions, and rates. When you say ratio, the ratio is the relative magnitude of two quantities of a comparison of any two values. So it is calculated by, dividing one interval or ratio scale variable by the other. So, example, there are 4 males and 6 females. Compute for the ratio of what is the male to female ratio. What's the male to female ratio?
4 is to
4
6.
is 6.
Okay. 4 is to,
Is to 6.
can you reduce that bit more into reducible?
2 is
Two
to
is to
3.
2 is to 3.
Okay, so it becomes 2 is to 3. Meaning to say, in a class or in a group of data with 4 males and 6 females, you will describe it into a more simpler form, or you will report the description of this by saying to me that the ratio of this class, the male to female ratio of this class is 2 is to 3. So, maintindihan na natin na there are 4 females and there are 6 males among a group of 10. Okay? You get my point? So it is calculated by dividing one interval or ratio scale variable by the other, so that the numerator and the denominator need not be related. So therefore, you can compare a male and a female. You can compare oranges to apples. Like for example, sa basket ninyo, there are 5 apples and there are 5 bananas. So what will be the ratio? of this apple to banana?
1:1.
1:1. So you know that for every apple, there is also one banana. Okay, that is ratio. Okay, you get my point? So in epidemiology, ratios are used as both descriptive measures and as analytical tool. When you use it as descriptive measures, you are just going to mention the male to female ratio, the exact number. But in analytical tool, so this goes beyond. Okay, ito yung mga kinocompute niyo, risk ratio, relative risk ratio, rate ratio. This is not for descriptive. These type of ratios are not for descriptive statistics or measurement. Okay, what we mean by a descriptive statistics when we talk about the ratio is you just give the ratio of the data. So 1:1, 1:2, 3:4, something like that. Yung risk ratios, these are for analytical type. This is different. So it will take us another topic to discuss this one. But we will not include that in our analysis na kasi we are not in epidemiology. So the numerators and denominators of a ratio can be related or unrelated. So a ratio to compare the number of males in a population with the number of females can be done. Kahit magkaiba ang male and female, magkaiba ang orange at saka apple. Okay? So you have to compare the number of residents in a population with the number of hospitals or the pesos spent. Parang gano'n. So for one hospital, ilan ang makakater niyang patient, kumbaga. So there is 1:10, or yung mga physician, there is one physician for every 10 patients. So that is the description that you can make about ratio. Okay. So usually the values of both the numerator and denominator of a ratio are divided by the value of one or the other of one or the other, so that either the numerator or denominator equals 1. Very simple. Numerator divided by the denominator times 1, that will become your ratio. Okay. So for example, there are 3,151 non-diabetics and there are 189 that are non-diabetic. Describe your data in terms of ratio. Can you do that for me? Can you compute? So what is your numerator? Your numerator will be the non-diabetics, 3,151. You compare it with the 189 who does have diabetes. Multiply it by 1. So that becomes your ratio. So what is your answer?
16.7.
16.7 is to
1.
1. Okay. Given with this number, parang mas mabilis intindihin kesa sa sasabihin natin na, yung data ko, there are 3,151 non-diabetics and 189 were diabetics. Parang ang bigat. Magkukompute pa ako. Ano yun? Ano itsura nun? Okay, but if you were going to summarize this one into a ratio or more interpretable one, so you just give me the ratio. So say there are 16.7 non-diabetic for every diabetic. So mas mabilis mo na siyang maintindihan. So you have given the description of your quite complicated data into a more simpler one. So they were able to give me the descriptive statistics in terms or in the language of ratio, so that you will now report that there are 16 or 17 diabetic for every one listed non-diabetic. Okay, do you get my point? Are we clear with ratio? So just
Yes,
like other dimensions, like measure of central tendency, dispersion, you can also use frequency to describe your data, specifically ratio. So when I ask you to describe your data using a ratio, this is how you're going to write down your analysis. Okay. Proportion. Proportion is the comparison naman of a part to the whole. So dapat, you are comparing a single or a homogeneous sample, no? Hindi pwedeng magkaiba. So, male among males or oranges among oranges. You cannot compare apple to oranges. Okay, when you want to compare apple to oranges, you use ratio. But if you just want to know the comparison a part of the whole, you use proportion. So a proportion is the comparison of a part to the whole. It is a type of ratio in which the numerator is included in the denominator. So you might just use proportion to describe what fraction or percentage of the population is younger than 25 years of age, for example. So a proportion may be expressed as a decimal, a fraction, or a percentage. Okay, so how would you compute for the proportion? So proportion will be the number of persons or events within a particular characteristics to the total number of persons or events of which the numerator is a subset. Okay. So the end here, you can choose between 100, 1,000, 10,000, okay? Para ma-reduce mo into terms. Kasi kung ang decimal point mo is 0.000001, okay, you have to reduce it into smaller portion para ma-analyze mo. And if you want to be in the value of 2 decimal points, which is equivalent percentage, you use the to the second power, which is equivalent to 100 times 100. Okay. So proportions are used most often as to this for descriptive measures. Okay, examples: the proportion of children in a village that are vaccinated against measles, or the proportion of persons who develop illness among all hospital employees in the hospital. Okay. Or like for example, yung pie na lang. This is a pizza pie. So if you divide this one into 8, usually 8, di ba? Ang pizza, 1, 2, 3, 4, 5, 6, 7, 8. Okay. So if I get this one, so what will be the proportion of this pie compared to the whole? Yeah. 8 slices. Number of persons or events with a particular characteristics. So, kumuha tayo ng isang pie. So, this will become 1 out of the total number, which is 1, 2, 3, 4, 5, 6, 7, 8. 8. 1 divided by 8. Ilan? Ilan 1 divided by 8?
0.125.
0.125. And you want to express that in percentage? In percentage is times 100, right?
0.5%.
12.5%. Okay. So this is the proportion of this pie is equivalent to 12.5% out of 100. Okay. Any question? So let's proceed to rate. What is rate? Rate is a measure of the frequency with which an event occurs in a defined population over a specified period of time. So a rate is a measure of risk, say. So again, rate can be used in two situations. For the non-epidemiologist, rate means how fast something is. But for you being researchers, okay, this will describe how quickly a disease occurs in a population. Like for example, 70 new cases of breast cancer happens for every 1,000 of women. So your rate is, there is 70 cases that comes every year for every 1,000 women. Okay, so that's how you will describe the rate. So you can see this in the incidence rate, attack rates, prevalence rate. So ito yung ginagamit niyong pang-describe ng data niyo. Okay, so we will not be talking about this one because these are more for epidemiological purposes. So any question with the use of rates, ratios, and proportion? So you just have to describe them. Rate is the incident. How often a certain value comes in a certain period of time. Ratio is a description
Prevalence.
of 2. Okay. And your proportion is a representation of a part from the whole. Okay? Are we clear with rates, ratios, and proportion? So that we can proceed with the next important thing that we're going to describe in your descriptive stat. Okay, can we proceed with the distribution of data? Okay, so a data distribution is a function or a listing which shows all the possible values or intervals of the data. So it also tells you how often each value occurs. So the data in a distribution will be ordered from the smallest to the largest, and graphs and charts allow you to easily see both the values and the frequency with which they appear. So that when you describe your data, you should also include your frequency distribution, which will be represented by a frequency table and a graph. So how would you going to do that? So a frequency table can be presented in 2 ways, using the ungrouped frequency distribution, and the second one is the group frequency distribution. So let's start with the group frequency distribution. So your group frequency distribution will be like this. So you put them into groups. Yeah. So the other one is simply mentioning them in a sequence or in groups in no. I'm telling it. It will be best explained by a picture. Okay. So this is a group frequency table because for every frequency, okay, you classify them into group. While the ungroup is like this. You don't have any particular characteristics that you put them together. Basta you have to just count it kung ilan yung respiratory infection. Okay, 25, cardiovascular issues, 12, 15. But for the group, you have to put them in a certain classification. So among 20 to 29 years old, there are 3 of them, etc., etc. Okay, so that's what we mean by the group and the ungroup frequencies. So let's start with the frequency tables on how the group frequency tables and how to create them. So like for example, I give you this age of patient. This is your data. 21, 25, 29, 32, 34, and so on and so forth. So if you count them, there are 18 patients, okay, with these ages. So how are you going to present them in a frequency table? Okay, so first, you have to determine the data range and grouping intervals. Then, you have to calculate the range. And so on and so forth. Pero, theoretical lang yan. Hindi ko na nga lang ituturo sa inyo para hindi kayo malito. Okay, so with this given data, 21, 25, I want you to describe it in terms of a frequency table. So these are the ages, 21 to 20 to 86. So you will present it in a frequency table. So bibilangin mo ngayon yung ilan, yung 20 to 29, you made groupings na. How do we determine the groupings? Okay, so you make your groupings depende sa choice mo. Okay, it is not thumbs rule na meron kang formula na gagamitin. So kung nakikita mo na it would be better to classify them into 5 groups, into 10 groups, into sets of 20, kung masyadong widespread yung data mo, it's okay. So for this set of data, we decided to group them in tens, okay? From 20 to 29 years old, 30 to 39, 40 to 49. So how many of those patients belongs to 20 to 29? So 1, 2, 3. So this is your absolute count or absolute frequency. How many of them belongs to 30 to 39? So 32, 34, 38. So tatlo din. So 40 to 49, 1, 2, 3. So tatlo din. Okay, so this is your absolute frequency. The problem when you present your frequency table using only the absolute frequency, you will leave your reader, okay, having a lot of questions. Hindi nila maintindihan yan. Ano ba yung 3? Ano ba yung ganyan? Ilan ba ang sample na inanalyze niya dito? So, magkukompute pa. Hindi kanya, iiwanan ka niya, hindi na niya babasahin yung report mo. But if you will provide a relative frequency count for this absolute frequency and even the cumulative frequency, your data will be easier to interpret. Because your relative frequency is the percentage that would represent your absolute frequency. Okay, so like for example, the total number is 18. So you get 3 out of 18. So what will be the proportion or the percentage? It is equivalent to 17%. For 3, it's 17%. So it is expressed in percent. So meaning to say, it will now be easier for you to interpret in terms of a relative frequency rather than just by reporting the values for the absolute frequency. Okay? The cumulative frequency will be computed as 3. You start with the 3 plus 3 dun sa susunod. So it becomes 6 plus 3, it becomes 9 plus 2, it becomes 11 plus 3. So until you have a cumulative, it's equivalent to the total numbers of the set of data you have. Okay, so this is how you are going to present your frequency, table. Are we clear? So this is another way of describing your data by presenting it in a frequency table. Your frequency table should at least contain the absolute frequency count and the relative frequency count. And if possible, you can also add the cumulative frequency. Okay. So your relative frequency will be expressed in decimal point, or better yet, transform it into a percentage para maiintindihan natin na. Okay. So this is another example of an ungrouped frequency table. Like for example, you recorded all those patients who came in at the emergency room at a certain particular time, and then you count how many of them has respiratory infection, you count how many of them has a cardiovascular disease, and so on and so forth. So kung ito lang ang i-report nyo, the number of admissions or the number of cases, parang ang hirap interpret. Okay? Kasi you still have to compute how many of them in total population. But if you will report them in terms of a relative frequency, okay, you will give me a picture in percentage or in decimal point. So this 0.31, this will be equivalent to at least 31%. So 15%. So di ba mas mabilis mag-analyze na at least siguro sa total ng, I will not be concerned anymore how many people came into your emergency room. But at least I know that 31% of all those patients who consult in the emergency room, okay, is composed of respiratory infection. Okay. So again, when you do your descriptive stuff, you also have to provide a frequency table. Are we clear on that? Are you still with me?
Yes, Doc.
Okay, we still have 30 minutes to go. So again, we were able to describe your data in terms of measure of central tendency. You know how to do that? Yes. We were able to describe your data in terms of the dispersion. You know how to do that?
Yes.
Yes. Now, we are going to describe our data in terms of frequency distribution using your rates, stages, and proportion. You know how to do that?
Yes.
Yes, sir.
And if I want you to present your data in a frequency table, you know how to do that?
Yes, sir.
Okay. Now, the last thing that you have to provide when you do a descriptive stat is the graphical presentation. So the graphical presentation will just be easy. So you just get an application that can transform your data into graph, like for example, your Excel. Okay, even your Word, I think, kung gagawa ka ng table, you can transform it into Excel and eventually automatically it will present, it will make you a picture. This is a graph, for example. So for our data here, okay, I just made a graphical presentation of your data so that I can understand or I can take a vivid picture of all your data. Okay. So you're done with our graphical presentation. We've discussed that on how to do what are the appropriate graphical representation for every data that you have. Okay, so in summary, if you're going to describe your data using a descriptive statistics, make sure that you will talk about the frequency table, produce a graph, and of course, the summary statistics, which is your mean, your median, your mode, standard deviation, your variance, etc., etc. Okay, so that you will now report it as it is in your analysis. So my collected data is all about having a mean of blah 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 blah. Okay. So are we clear? Marunong na kayong gumawa ng descriptive stat. Hello.
Yes po, Doc.
Okay.
Yes, sir.
Yung mga proposals na ginawa ninyo, di ba, hanggang methodology lang tayo doon. At saka yung na-collect yung data, now you are ready to analyze and make conclusion. So how can you conclude? Okay, by mentioning the summary of your descriptive stat. Okay, so for example, you are now going to summarize. Okay. So you summarize the descriptive stat. First, you have to determine the distribution pattern, present a graph, present the frequency table. Then you have to describe the measures of the central tendency, describe the measures of dispersion. Okay, so that it comes like this. And when you write it down, this is how you're going to interpret. My data, okay, is normally distributed, is skewed to the right, skewed to the left, with a mean of, a median of, mode of, a range of, and everything that you can describe to summarize your data will be appreciated. And it will make or paint a very vivid picture about the information of your data that you have. Okay? So descriptive statistics is all about describing and summarizing your data by reporting or describing what you see as it is in terms of the language of different measures of central tendency, measures of dispersion, in a frequency table, and in a graphical presentation. Okay. Are we clear with that?
Yes po.
Okay. Do you still have any problems? Are you still with me? O tulog na sila? O yung iba, wala na dito?
Re-reviewin ko na lang yung
Kaya
ano,
pa,
Doc.
sir.
Andito ba? Andito ba? Okay. So, simple lang, di ba? Simple lang, simple lang, simple lang. All you have to do is you gather your data, list them down, organize them from highest to lowest, and then analyze, compute for the mean, compute for the median, compute for the mode. Compute for the range, compute for the interquartile range if you want, you compute for the variance, compute for the standard deviation, and then present it in a frequency table, provide a graph, and there, you're done with your research. You can now conclude. Di ba? Simple lang? Umikot lang tayo ng umikot because we discussed the different details. Pero in short, madaling-madali lang. Again, sige. I have to ask you. You have the sets of data on your hand. What will you do next? What will you do next?
Organize.
Organize. Okay.
Arrange.
Organize mo na. Anong gagawin mo
Arrange.
sunod?
Analyze.
Analyze. Okay. How are you going to analyze? You can use two methods.
Descriptive and inferential
Okay, you
statistics.
can describe or you can infer about your data. So since ang kailangan lang muna natin, you just describe your data, that would be enough. No need to infer. So how would you describe your data?
Central
Okay,
tendencies.
by mentioning or describing it in terms of
Measures of central tendency. Mean, median, mode.
Median and mode.
then
Or measures of dispersion.
Self-dispersion.
Or
RD,
range, which is the range, variable, and standard deviation.
and then
Then the
along with that, you should make a painting or a picture that would vividly represent your information. And how are you going to do that? How are you going to paint your information? By providing a
graph.
graph
Graphs.
and graph and
Tables.
Tables.
table, a frequency table. I-summarize mo siya na ganito para maintindihan. So marami na siyang point of reference. So kung gusto niyang malaman ang information nung research mo, yung data mo, titingin lang siya dito sa summary, descriptive summary mo, statistical summary, and at the same time, titingnan din niya yung picture and titingnan din niya yung table. Then by that way, maiintindihan na niya yung information about your collected data or your research. Okay. Are we clear? Are you still with me?
Yes, sir.
Okay, very good. So one last thing na lang to. Di ba kanina we mentioned the distribution of your data. Why is it important for you to paint your data into graph? Because we want to understand the distribution, how your data is being distributed, okay, on the X and Y axis. Because their distribution affects the choice of your reporting or the statistical method that you use. Di ba sabi na natin kanina, the mode is for abnormally distributed data. The mean, the median, mode are for normally distributed data. So meaning to say, there's a need for you to identify if your data are well distributed or abnormally distributed before you can make use of those statistical measurements. Okay, so that when you collect your data and put them into graph or plot them, okay, there will be three possibilities that will happen to your data. So when you plot them down, it may produce a three shapes. It can be symmetrical, it can be abnormal. So let's say this is a normal distribution. It can assume three possibilities. There are other forms, but these are the most common possibilities that would happen if you plot down your data. If you plot down your data, we have this, it becomes a normally distributed or it can be abnormally distributed. So abnormally distributed if there is no symmetry. So ibig sabihin meron kang mga uneven distribution of data. For a normally distributed data, makikita mo it is evenly distributed. So most of your data are located at the center. For an abnormally distributed data, your data will gravitate from one side to the other side. This one, most of your data are located on the left. On this one, most of data are present on the right. They are not found in the middle. Okay, so those are the normal and abnormally distributed data. So these are the possibilities if you plot down your data. So if we try to draw them in a distribution, there will be three different types of spread that you will produce. Again, it can be normally distributed or become an abnormally distributed. Your abnormal distribution can be a positively skewed or a negatively skewed, meaning to say there is a tail that is present. Okay, so if a measure of symmetry if the skewness, so if we produce skewness, hindi siya symmetrical, this becomes an abnormal distribution. So what is a normal distribution? Okay, we call your data, or we view your data as normally distributed if the graphical presentation will assume a symmetrical distribution. Ibig sabihin, it produces a bell curve or a very nice symmetry. Parehas yung both sides. Okay, so when plotted on a graph, the data follows a bell shape with most values. Okay, we expect the most values are clustered around the central region, and then it will taper. Okay, as you go further away from the middle. So it is otherwise known as the Gaussian curve or the bell curve. So a normal curve is a smooth curve. The point in the middle is the mean, the median, the value of the mean, the median, and the mode. And the distribution is symmetric about the mean. Ibig sabihin, half of the values fall below the mean and half of the values will fall above the mean. So it is usually unimodal. Unimodal meaning to say, isa lang yung mode, isa lang yung peak niya. Okay, pagka bimodal, it becomes one mode, two mode. Multimodal. Okay, so a normal curve is unimodal. Isa lang dapat yung mode niya. So the distribution can be described by two values. The mean, okay, this will be the mean, and the standard deviation. So the distribution will be pictured or will be best expressed in terms of mean, median, and mode, and your standard deviation. Okay. So what about the abnormal curve? Okay, if one tail is longer than another, then that distribution becomes skewed. So pagka nagkaroon ka ng ganito, there is skewness. Compare mo ngayon dito, okay, smooth yung curve niya. Pagka nagkaroon ka ng tail, that will make the distribution of your data abnormal. Okay, so it depends upon the concentration. If they will be concentrated towards your left, this becomes positively skewed because the tails points to the positive side or in the right side. So this is otherwise known as skewed to the right or positively skewed. Okay. This one is also another abnormal curve because it produces a tail. The tail points towards the left. So it is negative, pointing to the negative side. So this is a negatively skewed curve or distribution. Okay. Are you still with me so far?
Yes, sir.
Yes, sir.
Okay. So that when you say a normally distributed data, okay, will be produced if the value of your mean, the value of your median, and the value of your mode are equal to each other. So if the value of your mean, your median, and your mode are the same, expectedly you will produce a what? Normal curve or a normally distributed data. Okay. But if your mean, okay, is less than the median and the mode, you will produce an abnormal distribution, which is particularly a negatively skewed type of distribution. Again, a negatively skewed distribution happens when the mean is less than the median and less than the mode. Okay. If the mean is greater than the median than the mode, if they are not equal with each other, okay, it will produce a positively skewed distribution. Okay, again, a positively skewed distribution, your tail points towards the positive side and a negatively skewed distribution, your tail points to the negative side. Okay. Are you still with me?
Yes, Doc, yes.
Okay.
Yes po.
So if you computed the value, you have your data, you computed for the values of your mean, your median, and mode, and you found out that their value are the same. What will be the expected distribution of your data?
Normal.
Normal. So it becomes normal. So if your mean is less than your median and your mode, what will be the expected type of distribution? Is it normal or abnormal?
Normal.
Normal. And what type of abnormality? Abnormality if your mean is less than your median and your mode?
Negative.
Skewed. Simply because your tail will be pointing towards the
Left.
left. If your mean is greater than your median and your mode, what is the expected type of distribution you're gonna have?
Positively skewed.
Positively skewed because your tail points towards the
Right.
right, and it's pointing towards the positive. Okay. So, Doc, gumawa ako ng nag-computation, yung mean ko, yung median and mode, hindi naman sila parehas. Pero ang difference is hindi naman sumobra sa 0.5. Okay, kunyari ang median mo is ang mean mo is 10, tapos yung mode mo is 10.1, yung mode mo is 10.4.
Normal.
They are still normal kasi the differences is not more than 0.5. But if your mean is 20, your median is 15, your mode is 12. Okay. What will be the expected distribution? They are not the same. So definitely it will produce an abnormal distribution of what particular type?
Positive.
Positive is good because your mean is greater than the median and your mode. And expectedly, you will provide or produce a positively skewed distribution. Okay, again, the distribution is very important in order for you to decide on what statistical vocabulary or presentation you're going to use. Okay, because for every statistical representation needs a certain particular type of distribution. Okay. So again, it's like that. Ito napag-usapan naman na natin. So if your mean is less than the median and less than the mode, what will be the effect? It becomes negative.
skewed.
If your mean is greater than your median and your mode, what happens?
Positively skewed.
Becomes positively skewed. Okay, so that's how you will determine. So parang ganyan lang. Naging the concentration of your data in a positively skewed distribution, much of your data are distributed on this area. Kaya mas mabigat siya. Mas marami yung data na nag-fall dito compared to this side. So it will produce a negatively skewed. Ito din naman, for a negatively skewed, the concentration of data, mabibigat ito, nandito sila masyado, kaya naging magaan yung tail. So it points towards the tail. So that's how you analyze it. And if the weight or the distribution of data is equal, okay, then it becomes a normal curve. Okay. So how are you going to determine? How am I going to determine if your data are distributed normally or abnormally? Okay. There are many ways on how you can determine if your distribution is normal or abnormally distributed. First, you can create a graph by means of using a histogram. So i-convert mo yung yung mga numbers mo into to graph. Okay, and then eventually, by just looking at it, you will see which one is normally distributed and an abnormally distributed. This one, what do you think? Is this normally distributed or abnormally distributed?
Normal.
Because it presents a bell-shaped curve.
Normal.
This one,
Sheet.
what do you think?
Abnormal.
Abnormal. What type of abnormality? Most probably.
Positive.
Is concentrated on the left. Your tail is pointing towards the
Right.
right. So therefore, this is
Positive.
positively skewed.
Positive.
So now you know that your data is normal or abnormal. Then that will dictate the use of your statistical method, which one is appropriate for you to use to represent or to describe your data. Kaya nga natin kinakailangan malaman yung distribution. Or you can also use the skewness. The skewness, you can use your Excel. Okay? So that in your Excel, if you analyze all the data points, it will give you a summary statistics. Your summary statistics, it will tell you the degree of skewness. Okay? Merong value makikita mo yung skewness to. So that, di ba, sabi natin, if the skewness is wala pa dyan. Okay, mamaya na lang. Okay, other form is you can also use other apps, which is your Minitab. The most common method that we use for a more hardcore statistical computation, we use the Minitab. Okay, your Excel is a very powerful tool, but sometimes may mga statistical process na hindi available doon. One of the most common applications that we use in statistical in research is your Minitab. Okay, your Minitab. The only problem of your Minitab is a paid application and it is very expensive. And usually nakikita nyo lang ito sa mga university or yung mga research centers talaga, no? Who can afford to buy this application. Okay, so you can also use your graphical yung scatter plot, okay, so that when your data, okay, adheres or is very close or is located in this line, most probably you have what? What type of data you have? Normal data, normal distribution. But if you see that the scatter is going away from the middle, then this probably is an abnormally distributed data. So there are many ways you can use, no? So in Minitab, ganito din. I-input mo lang yung mga data mo doon and then click on Analyze and measure the normality test. So what happens with your Minitab, it will provide you a graphical presentation like this. So it is a scattered plot. So the closer your data set adheres to the middle, okay, this will become normal. So the farther they go away from the middle, this makes them abnormally distributed. For the computation, your Minitab will provide you a value, which is a p-value. So lalabas dun sa in-input mong data is a p-value. So a p-value, there will be a decision that you have to make. If your p-value is less than 0.05, then your data is abnormal. Okay, but if it is more than 0.05, it becomes normal. So let's take, for example, we did the Minitab analysis and the p-value that came out is 0.94727. Decide, is this data normally distributed or not?
Normal.
Normal, because it is.
It is greater than 0.05.
And if you take a look at the graphical presentation, how would you interpret the distribution?
Close to the middle.
Okay,
Symmetric.
symmetric.
Goes to the middle.
So this is a normally distributed data. Okay? So we can also talk about the kurtosis. Kurtosis means the height of your uh, uh, distribution, but we don't usually make use of this in our descriptive stats. So we stick on the skewness. So as long as you know the skewness, if there is a skewness, okay, meaning to say that makes your data abnormally distributed. Okay, so for the kurtosis, there are applications that you can use. You can compute for the degree of kurtosis, no? So, but it's not for you to. There's no need for you to learn this one wholeheartedly, because these are for decision statistician. I'm just showing you that we can compute all the values of skewness and the kurtosis, so that if your skewness, kunyari nag-compute ka, if your skewness is 0, ibig sabihin there is no abnormality. So if your skewness is 0, what will be the expected distribution?
Normal.
Normal. If it is more than 0.1, it becomes skewed to the right. It is less than 0.1 o papunta siya sa negative, skewed to the
So that
left. So any values above 0.1 or below 0.1, this is not close to 0, will point to a direction or a presentation of an abnormally distributed data. Okay. Okay, that's all. And do you have any question? Okay. Why do we need to know the distribution of your data? Ang dami namang ek-ek neto, kinakailangan pang alamin kung ano yung distribution. Why? Why do we need to know the distribution of your data?
to know what statistical test to apply.
Yes, because there is a particular requirement for every statistical test, especially when you proceed to inferential statistics. When you do inference, when you use inferential statistics, it is a prime importance to determine the distribution of your data before you can select the appropriate statistical test. Like, for example, the parametric test, the z-test, the t-test, the chi-square test are for normally distributed data. The Wilcoxon rank, the progression, etc., is for like this, for different type of data. So it is very important to know upfront the distribution of data so that you can decide for the appropriate statistical tool or methods that you're going to use. Okay. So again, when you are asked to make a descriptive statistics about your data, what will be the factors that you're going to report or to describe as a part of your descriptive statistics? Again, this is just summarizing things up before we end. How are you going to describe your data again? Number one is
distribution and
okay.
frequency.
Central tendency.
Know the distribution of data. Okay. Sometimes you can identify the normality of your distribution by just making a graphical presentation using histogram. Okay, or the scatter plot para makita nyo kung ano yung distribution niya. And if you want to go further, you can use your Excel to analyze the degree of skewness, okay, or your Minitab, so that you can you can use the normality test there and decide whether your p-value is less than or more than 0.05. That will dictate if your data is normal or abnormal. So if you were able to determine the distribution of your data, what will be the next thing that you'll do? Provide a
Table and graph.
frequency table. So when you're done with that, now you're ready to compute for
Central tendency.
dimensional tendency, and then as well as your range, variance, and the different measures of dispersion. So that in your summary or in your conclusion, you can now write down all the informations in summary about your collected data. Okay. Are we clear?
Yes, sir.
Okay, so that ends our session for the descriptive data. So next meeting, we will be talking about the inferential statistics now. Okay, but first, again, we were able to vividly picture or describe the information about this basket of informations by giving you the summary statistics as well as the frequency tables and graphics, and that way you will now be able to present all the information that you want to your readers or spectators. Okay? Any question? Do you want to try solving a problem, or I will just give you anyway, I will next meeting I will give you an assignment. I will give you a case, like for this one. This is a case. So these are the hemoglobin level of your class. So I want you to report this one next meeting using descriptive stat. You will analyze this one. So I will give you for Parañaque group and for Bohol group, you will get 2 cases. I will post it on paper, and then siguro by group na lang. Ilan bang groupings ninyo? Ilan ang groupings ninyo? Do you have groupings in your class na? With
4 groups sa
4
Bohol.
groups. Sa Bohol, 4. Sige, gawin na lang natin 2 groups, 2 groups. Na? 2 groups from Parañaque and 2 groups from Bohol. So I will give you 2 cases each. So you next meeting you will present the descriptive analysis of this data. Kunyari, bigay ko ito. Okay, next meeting, choose someone who will report and do the analysis of this case in terms of descriptive statistics. Okay, is that okay with you? Yeah. So aside from reporting, you will also pass this individually. Kasi baka it will be very unfair for kung sino lang yung baka ang analyze lang ito yung magre-report. So that everyone will analyze, you will do your own description or your own analysis and pass it as an assignment. But for the next meeting, 1 or 2 of you will report or will do the descriptive analysis using the different cases that I will be sending you. Okay? Will that be clear for everyone? For example, I will give you a set of data. You have to describe your data using descriptive stat. So you have to make a frequency table. You have to make a graphical presentation. You compute for the different measures of central tendency. You compute for the measures of dispersion. And then you make a narration. O parang susulat mo siya sa paragraph. Okay? In order to make a conclusion. Okay. One more thing. Can you raise your hand if all of you or anybody of you who are familiar with the use of Excel? How many of you are familiar with the use of Excel? Excel. Kasi kung if you are familiar with the use of Excel, I think there will be no need for us to discuss on how to use Excel already, okay, in terms of statistics, okay? So most of you are familiar, I think, with the use of Excel. So that next meeting, I will still encourage you to do the longhand, no, the computation, and as well as you can double check it with the use of your Excel. Okay, so this is what you're going to do in your Excel. Wait. So, let me share my slide. Bibigyan ko lang kayo ng konting discussion sa Excel. Okay lang ba sa inyo? Mga 10 minutes lang.
Yes, Doc.
Para ma-appreciate niyo yung ano.
Yes.
Share my screen. So can you see the Excel file here?
Yes,
Yes.
Doc.
Okay.
Yes, sir.
So in your Excel, the use of your Excel in the statistics is very easy. So pinag-usapan natin pagkahaba-habang computation doon, you can do this pala in just very simple clicks. Okay. So with the use of your Excel, you can see that there are cells here. We call these cells, and these are rows and columns, composed of rows and columns. And we call this as a sheet. It's like a spreadsheet. And this spreadsheet can accommodate up to 40,000 logins. Napakahaba yan. So hindi mo mapupuno itong isang page. Kumbaga, this is equivalent to isang page ng Copenhagen. No? So this will be your Excel. So what you're going to do, if you are going to be asked, give the descriptive summary of your data, like for example, your hemoglobin, of 20 students, no? So you write them down, level of 90, 95, and so on and so forth. So this will be your set of data. So now you are going to make a descriptive stat. So what are the components of descriptive stat? The mean, the median, and the mode. So you'll be computing for the values of the mean. Okay. So if you want to compute for the value of the mean, you just put it in here. Let's just assume na wala pa yung mean. So the value of mean, in Excel, wala kang makikitang terminology na mean. In Excel, it is called average. Di ba, Dr. Sir Ray? Average ang tawag sa Excel.
Yes.
So that if you want to compute for the mean, you just put your equal and then sum. It is called sum in Excel. So you put the sum. Okay? Of what? So you just have to click this down, drag up to that point, and then press enter, and then there you have the mean. Okay? And then if you want to make median also, let's assume na wala yung median. Median is equal to the formula median. So let's look for the formula of median. So that will be the formula of median. The better way to do it is you click or you drag on the data sets, press enter, and then automatically you have the median and the mode. Then as well as the range, the variance, standard deviation, and everything. Okay, the better or the shorter way of doing it is you have, if you want a summary statistics, nako, nabalutan ako na. Yeah. Okay. So if you want to make a descriptive summary, you go to data. Okay, you click on data, you go to the analysis tools. Okay, kung wala pang naka-install na analysis tool pack dyan sa Excel ninyo, you can install it. You choose the analysis tool pack. Okay, and then after this is you go to formulas and look for data analysis. So pagka na-install niyo na yung analysis tool, you go to data analysis. Okay? And then you look for descriptive statistics. Okay. Click OK. So with regards to your data set, the input range, okay, the input range will be, you start with that title, label, up to the 20th set. Okay. Since you included your hemoglobin as your label, you have to click the labels in the first row. Okay. And then you determine where you're going to publish that. So that will be for your output range. Yeah. So where do you want to place your output data? So let's say you want to put it here. Okay. So we've identified the input range. The input range will be your set of data. Okay. And you click on the labels on the first row, the output range. This is where we want to place the descriptive data. And then you just press OK. Sorry. So ito, I forgot. You are doing a summary statistics, right? So you have to click on summary statistics. Okay. Then put OK. And then, boom. Nandiyan na lahat ang description na kailangan mo. So you can report. You already have the value of your mean, you have the value of the standard error, you have the value of the median, you have the value of the mode, standard deviation, sample variance, even the kurtosis. So what, even this kurtosis and skewness. Yung skewness is 0.1. So you can determine if this is abnormal or a normally distributed data, right? Or you can see the values of the mean. Is the mean equal to the median, the mode? Okay, mean 117, median is 116, mode is 116, magkakalapit sila. Di ba may decision rule tayo if the difference is more than 0.5. So mukhang magkakalapit sila, mukhang normally distributed dito. But if you try to see the skewness should be 0, right? But if it is more than
0.1.
okay, it becomes skewed. And if it is negative, so this must be an abnormally distributed data pointing towards the negative to your left. So this is a negatively skewed data. Okay, so you have the range, you have the minimum, you have the maximum, and etc. Now, after that one, you can make your frequency table. Yung frequency table, medyo madugo lang ng konti ito kasi mano-mano. So what you have to do is, given with this set of data, kunyari, ito kanina, hindi siya arranged from highest to lowest. What you can do is, if you want to arrange it from highest to lowest, you can select this one and go to arrange. Ano nga ba yung arrange niyan? At least meron dito. You can arrange your data. Kunyari, hindi siya arrange from highest to lowest. Hanapin mo lang dito. I-click mo lang. You just choose this one and then arrange data. Naka-cover kasi ng mga pictures kaya hindi ko makita yung tool. Anyway, so that's how you do it. Okay. When you do your frequency table, you decide your groupings. Okay, so with the range of 90 to 146, maybe you can group it by tens. No? So from 85, just make sure that the lowest number will correspond to a certain group. So we choose the 10 groupings. So from 85 to 95. So 96 to 105, 106 to 115. So you write them down dito manually. Okay, and then you go back to your data. How many are within 85 to 95? So from 85 to 95, to 95.
Dalawa.
Dalawa. Hindi ko madrag. Sorry ha. Okay. 90 to 95, you write that down. Dalawa. From 95 to 105, 103, 105. From 96 pala. Hindi siya. From 96 to 105. Right? So ilan?
Tatlo.
Tatlo. So, and so on and so forth. You put them down. So that will be your absolute frequency. Okay. Now you want to compute for the relative frequency. What you have to do is, pagka diretso ka na kasi dito, ayaw na Excel. Ayaw niya ng masyadong magulong data. So what you can do is you can copy this one. Okay. Copy. And you have to paste it somewhere else. Kahit saan mo gusto. Yan. So, dinuplicate lang natin yan. So, we would like to have our relative. So, instead of absolute frequency, your relative frequency. The relative frequency. Okay. So, how you're going to do that? Di ba meron tayong formula for relative frequency? Ano na nga ba yung formula natin for relative frequency? What is our formula for relative frequency? Tandaan nyo pa? Let's start with the ano muna, kalimutan ko yan. Copy number. Frequency
operated over na total number.
Yan. So frequency is equivalent to frequency divided by the sample size. Tama? Okay. So you get the frequency, which is 2 divided by sample size natin is, ilan yung sample size natin? 20. You can use your 20 high sample size, i-sum up mo lang ito. Yung number of cells, and then makukuha mo din ito. There is also a formula. Okay, and so on and so forth. So that, pagka kinumpute mo ito individually, magkakaroon ka na ng relative frequency value here. Okay? So, ang lalabas dito is decimal. So you can transform this. You just click on that decimal sets and then transform it into percentage. Okay? Sorry, hindi ko kasi makita yung table ko. May mga pictures. So you just click on the transformation para maging percentage ito. So you now have your frequency table. Okay? And then ano na lang wala dito? Graph. So it's very easy not to make a graph. So just click on here. Insert. What type of graph are you looking for? Okay, is it a histogram? What else? Okay. Or a line graph, maybe, or scattered plot. Yeah. So depende na sa inyo kung anong gusto nyong representation para ma-picture nila. And that makes your descriptive summary or descriptive statistics. So this is how you're going to report it on next meeting. So I will give you the assignment, you discuss this, and then do it individually para matuto kayo, ha? So follow this one. Kung ayaw nyo maglong method, you can always use the long method and then i-double check nyo with the use of your Excel. Okay? I think you are adept with the use of Excel naman na. So this is how you do it. Okay? And this will be the content of your descriptive statistic or summary. Okay? So if you are into action research, you don't need to go further. You don't need to do the inferential test. But if you want to test or challenge relationship, then you can proceed to inferential statistics using all this data. Kasi hindi ka makakapag-proceed to inferential statistics without all this information. So the descriptive inferential statistics will be the continuation of your descriptive stat. But you can stop at the descriptive stat if that's what you want. If your design is for descriptive design, then you can stop at that. But if you want for analytical one, you go for the inferential testing. That is what we're going to talk by next meeting. Okay? So, anything more that we need to answer or deal with? Okay.
Sir, question po regarding the reporting.
Ay, Dr. Krishna, sige.
Di ba po, sa Paranaque group po kasi one group lang po kami, 6. So,
Sige.
ilan po magre-report sa amin, Doc? Isa lang po or
Gusto niyo ba dalawa? Kaya niyo ba dalawa? Although unfair kasi 6 lang kayo.
isa na lang po? Doc?
Isa na lang, Doc.
Sige. So yung 3 ibigay natin sa Bohol group. So
Thank
3
you, Doc.
case ang gagawin nyo sa Paranaque isang case. But still I will publish all these cases, no? Para you can practice doing this procedures para magiging expert kayo, especially in the use of your Excel. Okay, so let's repeat. For the Paranaque group, you will report 1 case, and at the same time, individually, you will make a report and upload it to Canvas as your individual assignment. And then 1 representative from Paranaque will report this case on how did they perform or they did do the descriptive statistics. No? So you will teach us on how you did it. And the other groups can audit or can ask question on how you did it. Okay? And vice versa. Pati yung kabila din, ganun din. Kayo din, i-audit din kayo ng mga klase nyo. Tatanungin kayo, paano nyo ginawa ito? How did you arrive with this? What's the principle behind? Okay? So, tama na. Let's end this session. And I hope to see you next. Okay? Not unless mayroon pa kayong gustong tanungin. Maliwanag naman na lahat, no? So, madali lang ang descriptive stat. So, those are just the points that you have to discuss. With all this, I would like to thank everyone for your time. Nag-exit tayo ng 30 minutes. Masyado tayong madaldal kung ano-ano pinag-uusapan natin. But anyway, thank you everyone, and see you next time.
Picture, Doc.
Bye-bye.
Thank you, Doc. Thank you very much.
Last picture, Doc. Last picture, sorry.
Open cam.
Meron ba sa inyong nakapasok dito na hindi dumaan sa Canvas? O nakadaan kayo lahat sa Canvas?
Ako, Doc, hindi po.
Doc, ako kanina, Doc, nag-lock yung canvas ko, Doc.
Ay, hindi nyo na-open yung Canvas? Si Doc,
Hindi po.
sino pa yung isa? Kasi yung attendance nyo, baka hindi kayo si Ed Shield. Dr. Alal, nakapasok ka ba yung Canvas na?
Yes, sir. Nakapasok ko sa Canvas.
Okay. 1, 2. Si Ed Shield tsaka si Doc Cas. Okay. Are we done?
Yes, Doc. Nakuha ko na, Doc.
So thank you. Thank you, everyone. Bye-bye. See you next time.
Thank you, Doc. Thank you very much, Doc.